Bullshit, I can't hear you. Sound off like you got a pair.
Ooh, hey, Gumby. Yeah, sorry, I'm a bit late tonight because I was having family dinner. And it's like one of the few times a year I actually get to go see them all. So I stayed a little bit later than I should have. Alright, getting everything spun up now. But the good news is, I don't have to work tomorrow. So, the stream ends when I damn well say it does.
Incoming transmission from Marano Gumby. Do you want a cookie?
No, I don't, because I actually had so many. I ate way too much at family dinner. Alright, I got the seed run for Stinger going. For good old HackBot. Well, in theory, it's stuck. Suboptimal.
Incoming transmission from Mariano Gumby. I'm trying to finish today's Avant Cyber. Can you watch for the kickbots?
Yeah, man, I got it. They usually always like to come in around between 4 and 7 minutes into the stream. Shut up, Frozen Baby, I know it. What's up, man? Happy Sunday.
Incoming transmission from Mariano Gumby. Thanks.
And I had a happy Sunday. It was good. All right, let's kick this off. Let me see if this is actually going to work. Let's see what happens here when I push the button. Is it actually going to capture the correct part of the screen? Hey, it did. All right. I don't know what just happened here, but I tried to do the initial seed run, and it just flat out was not having a good time. What is going on here? Let's try this again. There we go. For some reason, it just got stuck on the initializer node when I was setting up the seed run. But what's up, everyone? Yeah, so sorry I'm a little bit late tonight. I had family dinner with everybody. Hey, Guy, what's up, man? Hey, Monkey. And it was a really good time. Kids were having a great time until my poor little nephew tripped and busted his lip. Poor kid. And it was so funny because my nephew and his wife are expecting their first baby, and she's just ultra pregnant. And she's watching the kids play like dodgeball in the backyard. And she's like, "Oh no, they're playing too rough. Look, he's like hitting him with the balls. Like, that's how dodgeball works, sweetie." I don't know if she has any brothers. I forgot to ask. And so it's like, the kids get busted, they start crying. I go out there, it's like, "Hey, what's wrong?" It's like, "I got hit in the cheek." I was like, "All right, walk it off." They just keep playing. All right, cool. We got this going. So last night, guys, by the way, the exploit agent did a really good job. It got a solid A- as after all the work we did to it, getting it all fixed up, getting the state management done. And we do have some more bugs that we got to go look at. But I'm just doing the seed run right now. When it gets to the exploitation agent, I'm going to kill it. All right, there we go. So seed run should be done. I don't know what is up with this rendering system here, where it's like putting all these nodes in weird places and stuff. Anyway. But yeah, so that's why I'm a little bit late tonight. But also, I don't work tomorrow, so I don't have to like be off at any particular time. You know, Sock doesn't have to know that. She's going to pass out in like probably 20 minutes. All right, let's see here. So we had a couple of issues we noticed in here. What's cool is it did error corrections, but it didn't operate exactly right. So I think the first thing we need to go do is we need to take a look at. So for some reason here towards the end, we didn't get any context back after the initial access exploit. So we got to go double check that, figure out what happened there. It lost all the context to that. But after that, I think we'll be solid. Actually, we'll take it back. We got to figure out what happened there, why the context dropped, and then after that's done, we need to go look at what is it? We need to go look at the exploit agent's prompt. That's what we got to do. I'm off for 2 weeks. Nice, jealous. I'm just off for this week. I took the week of Christmas off. Week of New Year's, I'm going to be working on a report for that 5-week pen test we just wrapped up. See, I probably could have taken Christmas and New Year's off. Actually, I take it back because this report had to get knocked out for this this pen test we just wrapped up. So it was going to be one or the other. I decided to go ahead and take Christmas week off, and I'll just work the week of New Year's. All right, so let's see here. So here is our get PHP web shell dice code that came back. And then on the exploit update, oh, that's weird. The step updater shows no input data, no output data. That doesn't seem right. Hold on. Why is that not showing anything coming back? I mean, we see it in here. We see it run. It ran a who am I check, got TripDub's data back, and the revisor sees all that information in here. What happened to the revisor? Hold on. The revisor even says we saw this. Yeah. Yeah, so it's up here in this data blob that we sent it. All this JSON stuff. Oh, wait, there it is right there. Yeah, tool call. And the tool call was call Diceco with the target URL. Bam, bam, bam. Okay. So it should have been good. Oh, I'm actually on call, but we were on a change free, so it shouldn't be much coming through unless something with AWS goes down again. Yeah, no kidding. It's no coincidence that the CEO of AWS just said it's stupid to stop hiring junior developers. I think they realized that AI is not a replacement, it's an augmenter. Let's see. This actually was not something I had expected. So why is the step update always showing like nothing in, nothing out? The data is obviously getting stored. Okay, it makes sense after the browser agent gets called. So after rename file, we should see something in here, but we don't. All right, let's go. Actually, this is kind of odd. Let me go double check this because even though it says nothing coming in, nothing going out to this node, there is data coming in and out. So if the last message type was a tool, which it should be, because here's the graph structure, right? So the exploit step update only comes back whenever it goes through this section here. I wonder if we shouldn't just reroute this, have the special agent go directly to the revisor, and not worry about this here. Let me see how I put this together here. So here we say no tool call output found. Yeah. I think we should go ahead and do this. Let's reroute this. The special agent node, we're going to hard link it to the revisor. So there'll still be a loop in here. It's going to be a shortcut loop. And we'll have to say that the special agents have to basically handle their own state updates. No, I actually don't like that. I'm going to leave it as it is for now. I'm not going to worry about that. Hey, Bobby, what's up, brother? Happy Sunday. What do I have up here? Oh, I have it to do in here. Actually fix this to test the initial access exploit. I think I did that. Oh, I see. Okay. Yeah, this is the validator. I forgot about that. So that's this node up here, which is if we, for some reason, if we get a task, let's say we've got multiple hosts in the environment and we get one that says, hey, we need to go, we don't have a, or for some reason, let's say the exploit agent gets a task to go exploit a target for whatever reason. It's a corner case. The exploit agent would then do a pre-flight check to the validator, and it should check to see if there's initial access exploit in there. So that's in the validator. That's not something to worry about. What about up here? What did I have? Oh, actually, I already did that one, so we can just get rid of that. What's my other to-do I put in here? Oh, we did that too. Nice. Boop. Yep, we fixed the thing where we're handling the scratch pad now, so the... What is it? So the LLM doesn't have to like regurgitate all those tokens back to us. So we did that. Let's go take a look at the prompt again real quick. Actually, hold on. I got to figure out what happened here. So in the trace, this was where the issue came about, right? So when we call the step processor, here's what a successful call should look like, right? Do I need to reload this? What happened? Hold on, this interface is looking funky. I don't think it loaded correctly. Okay, there we go. That's why everything was looking funny. See, now we're getting stuff back. Just the interface was just, I guess, hosed up. What was our last message in here? It should be something like... Yeah, we have a tool message as it's coming in. We have all this information here. And then for output... Okay, there we go. We have a pending tool called output. So let's go double check that task real quick. Let's go do some digging. Yeah, I hope everybody's got a short week this week, man. So this task should have been... create the initial access exploit, and here's our scratch pad. We haven't gotten down to this one, which is verify the initial access exploit. So here's what we had. All that right there. So it should be this information right here. Just like that. All right, so it's in the scratch pad. The reviser even sees it, says it's all good. But then for some reason, if we look at here, we don't have anything. Like the context just disappeared. So what happened with that one? Actually, let me check one more thing here. So when we returned all this data, okay, good. This was set to working. So the very last step was good. We were set to working in here. And then what else could it be? And just for comparison's sake, so again, here was the issue, right? The language model call didn't know what we were doing in here. You have to remember, these language model calls, they're stateless. They only give an appearance of state because we are tracking data in what's being sent to and from it. So it didn't know about anything else we had done because for some reason, all the context disappeared. So let's go take a look at... Let's go take a look at that. What did the successful one for this prior look like? So here's our processor. And see, it should have had all of this, previous exploit steps. So why was all of that missing in here? All that information of what we had previously tried and done was gone. So what happened when it hit that very last step? It got the task correct right here. Verify previously generated initial access exploit with the pwd command. That's so odd that it dropped it here at the last second. Let's go take a look. Maybe there's a missing step in the processor.
I'm back, baby.
Hey, Chris, what's up, brother? Happy Sunday. All right, let's look here. All right, so we pull out the exploit task, and then we pull out whatever the current exploit step is. I think I want to redo this one. No, undo that. Let's refactor that name real fast. So after we pull out all the step information, we then get the current step of what we're working for. Do we use this anymore? Is that literally the only place we're using this here? All right, let's simplify this real quick here. Let's just pull this out directly. Right here. Why was this set to, oh, this was at the exploit step formatter? Jeez. That's why all of these were so wrong. Remember how the type checker kept throwing an error? It's because these should have been exploit steps, not the exploit step formatter. Oh, I'm an idiot. And actually, I don't even need this anymore because this actually shouldn't be an exploit step. This should be a string right here. Do this, take that line out. There we go. We're going to clean this up a little bit, make it a little bit more streamlined. Everything looks like sorcery to me. It's more art-striking inspiring than anything. Thank you for sharing the home labs. Dude, I like it. I like doing this. This is a lot of fun. Plus, I get to meet really cool folks that come in and give me tips on things to look at. So the problem we ran into here is that for some reason on the very last execution, I don't know why I put this in here, honestly. Check if on the last task, testing the initial access exploit. Okay, but why did we put that in? I don't get why why would we change the, because I don't think we've used the working memory hardly for anything. That would explain why it wasn't working though. So we could use the working memory, we just don't need it. But that's what happened here. I see what happened is that the working memory, in fact, we're just going to take that out. Because we're not having to need the working memory right now. So let's get rid of that real fast here. I put it in because I thought we might need it, and turns out we don't, so we're just gonna kill this. Yep, we'll take that out, take that out. Broke something else down here. Yep, take that out. Because we're not using the working memory anymore. All right, so we don't have to worry about that now. And what we need to do now is come down to that processor again. And this part right here just needs to be gone. We're not going to be using this. We're not going to be using that either.
Incoming transmission from Morano Gumby. All down Blaise back. That malware challenge for today was rough.
Oh, dude. Which link me to that challenge you were doing, Gumby. Because eventually, I'd like to mess with those a little bit. I don't know when I'm gonna have time to, but I still want to take a look at them. And so everything for the state table monkey is being stored in memory as we're going through this. Eventually, I am gonna add a database where we could store this kind of data, but we really haven't needed it. It's not meant to be necessarily persistent against it. I might go through and add that in. I'm still debating on like why I might want to do that. Actually, later on we will add it in because eventually I will want people to be able to go load up what they had done in previous attempts to get through it. But that's like a ways down the way. So right now, all of the state data is being stored in memory. Remember, for the exploit agent, we have a dirty hack in place here where, so we can just run the exploitation agent without having to go through the entire, stinger graph here to get back to the exploitation agent. Where's this? We have this one to load the memory from disk or save it to disk.
Incoming transmission from Morano Gumby. Got to log back into my VM, but I got you.
All right, man. Muchos gracias. So, as a dirty hack that allows us to just run the exploit graph directly, we have this load pickle function in here where we can go save a pickle of this graph by itself. And so it's just like we first started in here. So all this function does is it checks the state table and sees if it's populated. If it's populated, it saves it to disk. If it's unpopulated, it loads it from disk. So when I do the initial seeding run at the beginning of the stream, that's how that pickle file gets saved to the disk. All right, let's see here. Well, actually, I think that might fix it. What thread was this? Does this tell me what the thread ID is? That's not bad. We've spent way more in tokens on that in the past. Okay, so it did do a couple of other things though. We got to go dig through this real quick because in here, when it hit the first block, let's see. So here's where it tries to do the upload. I think the first upload, let's check. So if we look at the summary from the language model, what does it come back with? It says, yeah, PHP not permitted. Okay, cool. So this is where it kind of blocked up right here. So we need to go probably work on the prompt for the exploit revisor because if we look at what it did, is it came through and it modified. Cool thing is it tells us what step we're working on. Working on step 3C4E9. Okay, cool. So if we look at what it does though, required actions, increment the iteration counter, keep the statuses working, provide a revised atomic step to bypass the filter. And then when that happens, it comes through and it modifies 3C4E9 to rename it. So what it should have done is it should have created a new exploit step here and inserted it. So let's go take a look at the prompt for that. Ah, there we go. Gumbe sent it out. Let me see that. Oh, that's from the Try Hack Me Advent of Cyber. Gotcha. I didn't realize it was the Try Hack Me one you were doing because I haven't actually looked at the Advent of Cyber. Let's see, what was today? What do they do for prizes on this? Looks like there maybe is like an Apple TV, some AirPods, a couple other thingies in here. I see good old John Hammond in there. Let's see. So this one have been, was this the one you were working on, Gumby? Tinsel Triage? Hey, Ford, what's up, dude? And Bluebug, welcome in. Happy Sunday. I was working on a side quest, but work got in the way. How dare it. It doesn't tell me what the days are. But I'm thinking that was, I guess, maybe the one for today? Because one of them was a password cracking. This was Sock Alert Tinsel Triage. Let's see. So the best festival company security operations center is in chaos. Screens flickered, lights flashed, and the sounds of alerts echoed through the room like digital thunderstorm. The elves rushed between consoles, their faces lit up by the glow of red and orange warnings. It was raining alerts, and no one knew where the storm had begun. Oh, this is day 10.
Incoming transmission from Marano Gumby, that is day 10.
Oh, here we go. I saw the thing like get darker. I was like, oh, okay, I thought that was done then. Oh, I see where they're unlocked. All right. Okay, here we go. Malware analysis. Malware. Who is that? I don't know that. I don't recognize her face. Here we go. Day 21. Let's see. So, and in our kingdom of Warville, just like in others, thousands of files of all kinds pass through the system every day. From docx, PDF, resumes received by our elves to financial spreadsheets, CSVs, and from the accounting department, and executable files launched by different applications. That's a red flag. That's pretty cool, though. Oh, it's an HTA file.
Incoming transmission from Marano Gumby. Yay, it wasn't that hard. I'm just a noob and suck at lol.
Dude, I suck at malware reverse engineering. It's not one of my strong suits at all. All right, so back over to this. So what we ran into here was it did not insert a new step. It modified the current step. But if we look at the reasoning that it had, okay, in this case, it chose to revise an atomic step task to bypass the filter. All right, so let's go take a look at the prompt for this. Maybe after I finish the exploit agent, I'll take a quick side quest to bust all these templates out into markdown files. So this will be a lot simpler to go modify.
Incoming transmission from Marano Gumby. Yay, JH can do it so fast. Wish I was on his level.
Well, I think his specialty is in threat hunting. So they're used to something like that. Same thing with low-level learning. I believe that was one of his well, reverse engineering I know is one of his specialties. I don't know if it's specifically related to malware or not, but he has reverse engineered quite a bit of malware. It seems like a lot of malware is just straight up insanity streaked with brilliance. Pretty much. Because a lot of times what they're doing is they're finding interesting ways to abuse the operating system.
Incoming transmission from Marano Gumby. Just get good, noobs, hee.
Yeah. Have you tried getting good? I understand there's tariffs and everything right now, but you can still get good. All right, let's take a look here. So this is the section that talks about what to do if a step fails. So if the step did not complete successfully, use the following criteria to update these steps. And I added this array portion in here. Always increment the current step iteration field by 1. Analyze the step scratchpad for historical attempts to avoid trying previously failed revisions. Provide a revised step task that corrects the error or blockage. Okay, so this is where the error came in right here. We need to expand on this. Maxbane, what's up? Welcome in. Let's see here. All right, so the issue is it followed our instructions very literally, which was a nice breath of fresh air after Claude 3.7 was just absolutely ignoring them. And we literally told it, provide a revised task that corrects the error or the blockage. We need to tell it, you have the ability to go create a new one. Let's see. We'll tell it if the step needs to be modified. Then we'll do this part. Actually, yeah, let's do this. Then provide a revised step task to it. Yeah, let's take that line out. Let's come back right about, yeah. And then we'll do one more under this. We'll give it another instruction. If a new step is needed, to bypass the blockage, create a new step based on the, what did we send this? Hang on, because we're actually sending it the shape of the exploit step, aren't we? No, we're just doing exploit step updates, but that's fine. We'll just tell it if a new step is needed to bypass the blockage, create a new step, create yeah, I want to say this. Okay, yeah. Hey, Ty, what's up, man? We gotta lurk and catch up on where we're at with the auto hack the box project. I'm tinkering with some hilariously insecure Chinese DVR at the moment. Dude, DVRs are so bad. There's been so many times I've gotten into companies, or at least gotten a foothold in the environment from their DVR. They're hot garbage. DVRs were the original IoT device. Let's see. Okay, so we'll say this. If the step needs to be modified, then provide a revised step task that corrects the error or blockage. Take that out. So if a new step is needed to bypass the blockage, oh yeah, we'll just say grid and insert it into the steps array. Are you for freaking real, man? It has a port knock backdoor where it'll just give you a telnet show. No. No. All right, so real fast little aside here. Let's go to the whiteboard of knowledge and failure. Is usually is my case. So if you're not familiar with what a port knock is, sorry for the flashbang. A port knock works like this. Say for example, you got a target server sitting over here, right? And on that server, you've got some kind of a firewall running. And typically, let's say we had just had port 8080. It's open, but the firewall is blocking it, right? So the firewall says no bueno. But let's say we had a couple other ports open over here. Maybe we've got port 1, 2, 3, and then maybe we've got port 4, 5, 6, something like this, just as an example. There's a lot of other ways to do this. So what would happen is an attacker comes over here and initially checks port 80, sees that it's closed. It's like, okay, port's closed, nothing to do with it. But what you might not realize is if you were actually to send maybe just a connect packet over to 1, 2, 3, and then send another one over to 4, 5, 6, And let's say they're really crafty. They've got it set up where maybe you just have to send another one back to 1, 2, 3. So you've got this like knocking pattern, like shaving a haircut. Then if you go and you try to access 8080, now all of a sudden it's magically open in the firewall. That's what a port knock does. And there's lots of ways you can configure this. You can configure it where you have to send a particular TCP packet with some flags set to it. Then it's going to hit it up in here. So yeah, that's how this works. And I'm not saying I've used port knocks in the past, but I've totally used port knocks in the past for lazy obfuscation. And yeah, so this term is called a port knock. And so it's just like you're knocking on a door with a secret code. Yep. So what Max was just telling us is that he found a DVR that has a port knock code built into it that just opens some port to give you a telnet shell, like probably an unauthenticated telnet shell. Oh God, that's so bad. And what you can even do with these is you can say, okay, this is only going to be open for like 15 seconds in here. And after 15 seconds, the firewall closes the port again. So you knock, you've got 15 seconds or whatever to go connect to the box, and then it's not going to allow any new connections to come back. So if your connection died, you'd have to re-knock it, but yeah. Yeah, someone must have actually coded that in, Gumby. That's not something you put in by accident. Nobody accidentally puts in a port knock. That was deliberate. That's so horrible. That is terrible bad. Oh my goodness. That's the funniest thing I've heard all day. All right, let me see. Where was I? Right here. Okay. Actually, I think I want to move this. I'm going to do this. Actually, let's do. I'm going to do one more thing. We're going to give it a more like a conditional branch here. You may modify or add. Modify, add, or delete new steps. Yeah, there we go. And then what we're going to do is we're going to bring this in a scope line. We're going to say, there we go. So if a step needs to be modified, then provide a revised step task that corrects the error or blockage. If a new step is needed to bypass the blockage, create a new step and insert it into the steps array. And I'm going to put one more in here. I'm going to give it one more instruction. In the extreme case, you may also remove steps that are no longer needed. Actually, let me move that one down. I don't know what I just did there. There we go. Bring that right there. Okay. Yeah, so we gave it an option to where it could modify it with a revised step task. If a new step is needed to bypass the blockage, create a new step, insert it into the steps array. And then what else do we want to say here? I think that might be it, actually. If the steps array has become degraded, actually, what do I want to do with that? Let's see. So I'm totally new to cyber. I'm the type of person that buys a bunch of courses and resources and slowly finishes them. I want to understand as much as possible. That's great. I mean, dude, if that works for you, that is a great way to go about it. Typically, what I recommend folks do is pick one topic that really interests you and kind of go deep in that one. Because a lot of the security concepts don't just reside in a single silo, they can translate into other areas. So if you get really good in one area, it's going to help you understand how to translate that into other areas. Oh, the shell is off, but there's a lot of those passwords online. Root shells to BusyBox. Gotcha. Dude, BusyBox is a pain. I'm trying to think about this. Let me take that out. I don't want to say here. We'll say that. So if a step in the array is no longer needed after revisions, it can be removed. I'm gonna say from the returned output. There we go. Boop. All right. So hopefully that will fix that little bit of an issue there. So we fixed the issue where it was messing up the initial access exploit. And then we've also fixed the issue where, what else did we fix? We fixed the issue where it was incorrectly handling how to bypass blockages. It was smart enough to realize, because we gave it enough context, how to bypass that, how to get around it, and how to error correct itself, which was good, but it shouldn't have had to do that. That was the kicker with it. Oh, Ty, I didn't know that, man. I hope she's doing all right. Dang, y'all been married 32 years? That's crazy, man. My wife and I just had our 11th anniversary a couple months ago. And I was like, dang, it didn't feel like 11 years, man. All right, let's make sure this all saved and hot synced, and then we'll go run another test on it. Looks like it did. Excellent. So let's do us another run here. Damn, Frozen, you've been married 22 years? Holy crap, man. Literally twice as long as me. I feel like a lot of these cheap IoT devices are going to have these kind of backdoors. Not necessarily malicious, but maybe just for shortcuts for updating and monitoring. I mean, possibly, yeah, but what I forget who was asking it, but yeah, you don't accidentally put in a port knock, though. Hey, Peaches. I missed you too. I was gone most of the day today, so Peaches is like, pay attention to me, love me. Damn, Palmer's coming in here hot too with another 32 years. Holy cow, man. Let's see. Oh, there we go. I just saw it say it was going to insert a new step. Nice. Nice. Let's let it cook. We'll see what it does. It's doing stuff. It's doing stuff. This is amazeballs. It's doing things. It's doing things. Why is it navigating again? Oh, it should have done a rename and then an upload. Okay, so it's trying to upload the PHTML now, so that's good. So much in here. It's confirming the web shell. Call PHP web shell diceco. It's running its trip devs data. Oh yeah. This is good. This is amazing. The initial access exploit code is complete and valid. Okay, so now it should be. It's going to test it with a Python exec. Oh, it's doing stuff. If it routes to an exploit agent, we know it actually thinks it succeeded. It went back to the processor? Why? No, it errored. Okay, it was doing so well though. Let's see what happened. I kind of expected that. Hey, not bad. 72 cents for that run. Not too shabby. All right, so what happened here? Let's do a quick breakdown of it. This is mostly the version that's up on Git right now, Ty. I made a couple minor modifications to it here. I forgot to log back into GitHub, so I didn't push the code from last night till just before the stream. So everything we did last night is up. This is a slightly more optimized version of what happened last night, and it looked like it got all the way through it. So let's see. So it gets the web shell artifact. It navigates to the panel. It attempts to upload, and let's just validate that that should fail. Yep, we got PHP not permitted, so it failed. That's awesome. So what does the reviser do here? This is the first test. It's like, how does it handle this failure of this step? So our current step is AOFDW. Attempted the upload. The result, the upload was rejected because PHP is not permitted. The blockage was the server has file type validation that blocks PHP extensions. So reasoning. The upload attempt failed due to server-side filtering of PHP files. Common security measure, the scratchpad clearly shows the upload was rejected, so this step did not complete successfully. Historical context. This is iteration 0, meaning no previous attempts. The error message is clear, PHP is blocked by extension. So the most common bypass by filtering is to rename the file to a different extension or use double extensions. And another solution is to try alternative extensions the server might accept. Okay. However, per instructions, I must provide one atomic revision, a single indivisible action. The most promising single action is to rename the web shell to use a different extension before uploading. So atomic revision. Since the current step failed and we need to bypass the filter extension, I will increment that iteration by 1. Insert a new step before the current step to rename the file. Nice. Keep the current upload step, but it will retry after the rename. Got it. The rename step will bypass most common bypass using a PHTML extension. Okay, so now if we come look in here, it gets the artifact, it navigates to the upload panel. We now have rename right here. And then we have upload the web shell file to the form. So this one knows how it's iteration 1 and this one is iteration 0. Because this is our new one. Oh, look it named it rename 1. That's awesome.
Incoming transmission from Morano Gumby BRB got to take the dog out.
All right, no problem, Gumby. Understand. Let's see. This one looks like potato. That cracks me up. Okay, cool. So we inserted a rename. We uploaded it. And We should be good here. Okay, so after this happens, the next one that it should work at when it gets the first working one is rename. Boop. Okay, so then it calls the rename tool. So we rename WebShell PHP to WebShell PHTML. That looks like it renamed just fine. The reviser should say, okay, that's cool. All right, so the next step, currently new, but should be set to working since the previous step is completed. Oh wait, did it set it to new? It should have left it as working. It's fine if it didn't, because it should have worked though. So after, wait. It calls rename. Okay, I just lost the scroll here because these little pop-ups are messing with me. So after the rename, it should come in and try to upload it now. So I'm going to help you upload the renamed web shell through the upload form. Boom. So it comes through here, calls the browser agent does its song and dance, and afterwards we get, I successfully uploaded the renamed web shell PHTML through the upload form. Boom. Excellent. Excellent, excellent, excellent. So then reviser should say, okay, that's good. Step's been completed successfully. The web shell has been uploaded to the target server and is accessible. However, RC has not yet been achieved. We've only uploaded the file. Okay. So then it says, okay, we're going to mark it as validated. The next step, which is this potato one, is to navigate to the uploaded web shell. Continue to test with common execution to confirm RCE. Sweet. So let's just step through it real quick here. So it's going to call the browser agent to go hit up the webshell.phtml. What was the actual task though? Wait, why did it? Okay, something went awry here because it's trying to upload it twice. See that? So it uploaded it here. Let's grab a copy of the state table from the reviser here. So what it returned, not the state table, but all the updates that it returned. Curious, if I just copy it like that, what's it going to do? Oh, it does give me everything. Nice, that makes it easy. So this is what it came back with. After the browser agent went through, did its thing, what does the reviser come back with then? Comes back with all of this. Let me copy that. And then let's compare these two real fast. So we have rename one in here, and then we have AOFDW as working. Oh, so one of them was an upload, and then one of them was a navigate to it. And then we have test the web shell. Okay, so that's why it did that. So here it navigates to it, takes a snapshot, comes back. It should say that, okay, yeah, we can see it, but this is common for web shells. Because typically, so the web shell is not going to do anything in this case, unless we actually browse to it and we send it a command URL variable. So this is all expected behavior. So now it's going to move on to step 125XO, which is test it with, confirm with code execution. Awesome. So after that comes back, the step processor says, I'm going to call it with the tool that we gave it designed for calling this particular web shell. Welcome back, Gumby. And then here it says, who am I? TripDub's data. That's all copacetic. So now let's see, what does it come back with? So current step was test the web shell to confirm command execution by running a system command. Scratchpad evidence. The agent called the dice code tool here. So we have RCE achieved. Remote code execution has been achieved. The web shell successfully executed the who am I command, returns TripDub's data. which typically runs on a Linux server. So awesome. So we mark that step as completed. We mark the create initial access exploit step as working, and then we mark the verify the previously generated. Yeah, that one should be marked as new. All of the remaining steps between the current and the last two should be marked as skipped. None exist in this case. That's actually pretty cool that it realized that. I'm not gonna lie, that is pretty sick. So we should be down here on this one. Create the initial access exploit for the target, which is a real easy tool call. We made it simple for it. We have basically, we have like a triplet of tool calls that we are giving the language model. One is to get the web shell artifact. The other one is to call it. And the third one is to get an initial access exploit for that particular web shell, which is going to be a chunk of Python code. So we get that back here. And then what does the revisor say? The revisor should say this is all good. So it returned this Python code. Whoop. Has a command holding place right here. Okay, so that one's going to be marked as completed. And then we're going to mark the last step, WJ Coom, as working. That's funny. And so then we're going to verify that by sending a pwd command. All right, so how's it going to do this? Let's see. So we come to the processor. What is it going to do? So I'll verify the generated initial access exploit by executing the pwd command. Based on the context, the initial access code was generated that uses Python. I need to execute this with the pwd command. So the question is here, did it insert this? It did. So you can't see it because my big old fat head's in the way, but there's the pwd command. It successfully inserted into the Python code. So what does our Python exec come back with? Comes back with var tripdubs HTML uploads. Perfect. All right, so what does the revisor come back with after this? Oh, I just realized. The reason why this all went good, it completed the exploit chain. It got the initial access exploit. But the task is still working, the overall exploit task. So we'll have to do a little bit more logic handling, but it's going good. That particular command only works on Twitch, Gumby. This is awesome, though. This is great. Okay, so what does the revisor actually say? Okay, since the WJ-Coom is the last step and RCE has been confirmed, the exploit task is complete. Great. Okay. So we need to put in another check in here for the exploit step router. Actually, I take it back. We need to put one in here for the... Actually, yeah, for the exploit step router. That's where we need to do this. So let's go take a look at that. So exploit step router. So in this case, what it's looking at is it's looking at... Now, why did that not come back as -1? Hold on, let's take a look at this. So what did the revisor actually return for this? It should have returned that all of them validated, 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 and validated. So we called our function here. So in this case, it said nothing was working in here. This would return an index here. I want to do one more for this. We're going to do one more. And we're going to say if the status equals new in here. Actually, do we want to do it that way? Yeah. And I'm going to break it up like this. Yeah, I want to do it like this. So it's going to loop over it twice, but that's fine. because what we're going to check is this first loop is going to check, do we have any that are working? And it's going to return the index for that. The second one here is going to say, do we have any that are new? Then return the index for that. Yeah, that's what we're going to do. What does this enumerate actually return? Could I actually store that in a variable to try and make this run a little bit faster? I think so. I don't want to try that. So then we only have to do the enumerate one time. The loop over this should be fairly quick, so... yeah, we'll do that. So the question is, why didn't it return a -1 from this? Because what should have happened here is if the current working exploit task, actually, hold on, I do want to undo that a little bit here. Because this one is specifically to get a working one. Checks the state table for the currently working exploit task. Returns -1 if nothing is found. All right. So how come it did not return a -1? Because none of these should have been working. I hope I didn't accidentally just hit the unmute while I was in the middle of that sneeze. If so, I apologize. So what happened here? This should have worked. What should have happened is, when it hit the exploit router, it should have gotten the current working exploit task index value. And that should have come back from this function. We pass in the state table, it pulls out the data, analyzes it. It's okay, Peaches. I'm okay. Yeah, I'm okay, Tweety. No, don't pull my headphones out. You're okay. You're okay. You're okay. I swear, anytime I sneeze or cough, she comes over like, you okay, bro? I was like, yes, I'm okay. Achoo. I am Achoo, son of a sneeze. That is so odd. What did the processor think it was working on? Let me take a look at that. Oh, it thought it was working on this. That's why. Okay, so I think what we need to do is revise this. This can return an int or a none in here. I think is it capital N? There we go. And in that case, then what we're going to do is we're going to turn a none. And now the exploit agent is going to throw a fit, maybe? Will that actually work? Can you string compare like that? Let me see. No, that's not what I need. No, go away. What I need is the Python terminal. Let me see here. If I do x equals none, let's do if x equals none, print yay. Okay, so you can just compare them like that. All right. I'm not pooping laughing. I'm sitting right here, bro. All right, so for some reason the IDE doesn't like this. Okay, is none. There. Does that make you happy? So if the current working exploit is none, we're going to send it up to the exploit agent. And then our exploit step processor here. All right, let's see if we can rewind this a bit. Let's time travel a little bit. So after this code hot patches in, should be good there. What we can do is actually come back right about meow. And what we want to do is from the revisor, we want to rerun from here. Let's see what happens. Okay, so it went back to the step processor for some reason. Annoying debug. Let's do this real quick. Is index. There we go. So we're going to save this, and then we'll get this back. So we'll figure out kind of what this index is right here. Pages, did you fart? Good God. I just smelt this doggy fart, like waft up and just punch me in the nose. Evident Cyber was much more involved this week. Should have broken it up into 2 streams, had I known. That's what Gumby was just working on. He was working on day 21 on reversing the malware. All right, did that all load in? It looks like it did. I'm going to try rerunning it from here again. Okay, so for some reason, it hit that, but did we get the annoying debug? So why is the current exploit task 0? Because if we come look here, we drill into output, steps. Is it looking at the current step? That shouldn't actually, we should probably delete that out because it's not important anymore. But none of these should be set to working. At least not according to our tasking function here. Oh, you know why? Get current exploit task. This is the exploit task. This is not the step. Oh, thanks, honey. That's what's happening here. Yeah. I'm an idiot. So this should not have been current working exploit task. So the reason why this was happening this way is because I was expecting the revisor to actually come back and emit this data back. That's what I was expecting. I was expecting it to set. Ooh. I skipped day 21 for right now, thinking about doing it on a Christmas Eve stream during that day, so I'll hit it in. Wife has to work Christmas Eve anyway, so I'm going to capitalize on the time. Well, originally I thought I was going to have a pretty chill Christmas Eve, but now my family's like, let's get together on Christmas Eve. I was like, all right, fine. Fine. Even though we did Christmas today, they're like, let's do Christmas Eve again. All these people loving me and taking up my time and attention. Good strategy to blame the pet. Dude, when I first got Peaches, she was chunky, right? She looked like a little Debbie Swiss roll with toothpicks for legs. She was round. She had all the chunk. And it's because she came from a couple that was they're retirees, and they just babied their dogs. And on top of that, she also was part of a pack of like 6 dogs that lived in the house. So constantly fighting for food, constantly giving treats, never really got much exercise or anything. She comes to live with us, and then she dropped like, I don't know, 15 pounds. And she's got her little girlish figure back, and she's happy, she's excited, she's jumping around, she does the tippy taps. She's in a good mood. And she had the worst gas when we first got her. It was bad. It was just like that one, except it was pretty much all day, every day, until we cleaned up her diet. And now it's like, it's an oddity whenever I do it. It was like, oh, peaches. Woo. Too funky. Too funky. All right, so the kicker here is, do we give... We could okay, so we could extend the revisor. Let's go look at the graph here. We could extend the revisor here and give it another tool to make changes to the actual exploit step, or the exploit task, right? So right now it only has the ability to modify the steps. We could also give it the ability to update, like basically to make a tool call here that's a return structured data that says the task completed successfully, right? We could do that. What's the best way to handle this? We could still actually do this. You know what we could do? We could leave this as is. We can just extend this out a tiny bit. So we have our output steps added over into the state table. What we could do here is we could say, up here we go get our current... Are we actually using this anywhere? I don't think so. We have to be using it somewhere. So we don't need this. This is all good. We're good here. Where's this actually being used though? Let's take a look at this from the top. So we get our current task. Oh, that's where we use it right there. So we do want that. That is the current task. That is the correct value right there. We get our current exploit task from the state table. So we have 2 of those? We do. All right, let me take that back out. Let's get rid of that. We save that. So we do get current exploit task. Okay, that works perfect. That gives us our exploit task index. Then we get the exploit task from that. And then we get our exploit steps, which is our list of steps. Current step is get current exploit step. Okay, so what we're going to do is we're going to run this again here. We're going to say current exploit task or step, we'll put in the step is none. Actually, hold on. I need to go back to this one. I'm going to change this also. This could return this, or it can return a none, and we're going to set this to a none value right here. All right. So if that is a none, then what we're going to do is we're going to say, I'm going to copy this up to, actually, yeah, I do want all that. We're going to set this. Do I really want to do that? If you ain't cheating, you ain't trying, right? That's what one of my old my old directors used to say of my first red team that I worked at. He's like, yeah, if you're not cheating, you're not trying. Gumby's hunting bots over on Kick. He enjoys the banhammer. Let me think about this. What's the best way to do this? We could either give another tool to the language model that if it emits that, we know... No, that's not going to work. I mean, it can work. Right now, what we're doing is we have it default to handling updates to the steps in here.
Incoming transmission from Morano Gumby at the power I have.
I have the power. Roberto, hey man, what's up? Thanks for coming online, brother. Welcome in. So what we're doing right now, Ty, is as it sits inside of our exploit task, right?
Incoming transmission from Morano Gumby M that caught the abuse is the bachihi.
Abuse. So Ty, what we've got right now is we have a set of tasks, right? And those tasks are meant for the primary agents. So those are handled by the primary agents. Underneath this, we have a field, which is our output field, which is supposed to be like, hey, what was the output from the task? Oh, Peaches. Peaches, you didn't crap in the office, did you? Oh, hang on one second, guys. I gotta let her out. I think she's about to dookie in my office. Hold on, be right back.
Incoming transmission from Morano Gumby. Don't let him lie to you, chat. It was him and he shot himself, hee hee.
No, Gumby, I was not about to crap myself. I did that before the stream. Had entirely too much food at my brother's house. I actually did go get some more water though, because I definitely needed more. Okay. Back to where I was. All right. So what we're looking at right now is it completed all the steps, but there's a containerization issue here. So the tasks that are handled by the primary agents down here in the output field. So in this case, for example, this would be our exploit agent right here. Exploit. That is Terabad. Exploit right here. That's our exploit agent. Down here in the output though, this actually contains a special type of task called an exploit task. And then this has a field called steps in it. And this is an array. That's not array. An array of exploit steps. So I know the terminology gets a little bit confusing, but they all have a particular purpose to them. So this right here is what the language model can operate on. It can operate on this entire array. The problem is up here, we have a status message that we need to update. So the question is, how do we want to handle updating this exploit task status to change it from working? Yeah. So that's what we're trying to track down, is where up the chain do we want to modify this? So what I'm thinking about doing is, if we get the current exploit step and it's none, then what we're going to do is we're going to change, where's the exploit task? Here we go. We're going to change this from working to validated right here. So our status here, so status is now going to equal validated, just like that. Boop. So this will be a real-time check right here. We'll put this into our state table. Our local copy of the state table will admit that back because it'll be as part of the task. I think we'll be good there. Then we can come down to the revisor. If this gets marked as validated, then this function here is going to come back and say, yeah, get current exploit task. This should return a none. So then it's going to say, okay, if that's a none, then we're going to pass it back up to the exploit agent. Now what's going to happen once it gets back up to the exploit agent? I know we're going to find out. Let's go run this again. We'll fork it and run it. Here we go. Rerun from here. So it should pass it up to the exploit agent. That... Is it running or not? Oh, because that was the exploits. Hold on. Do I need to rerun it from here? I think so. Rerun from here. Because I need it to rerun from a place before it triggers the router. I think it had already triggered the router at that point. So I would have liked to have avoided hitting that. That's fine. Okay, cancel. All right, so we do need to go handle, we need to figure out a way to handle this over in the exploit agent because it instantly routed it back down. Which is fine though. So if we come look here, the revisor returns everything is valid. Everything is valid. Everything is cool when you're part of a team. Excellent. So it routes it back up to the exploitation agent. Okay, so this one just looks at this directly. And then what did it output back to us? So execute commands through the uploaded web shell at here. Here's the reason. So what it does is execute commands through the upload web shell. But it's already been good there. We already have that. Oh no. Oh wait, hold on. We started the stream late, so I think I'm still good. I haven't added more time yet. There we go. Add another hour. Excellent. Hold on. I've been burned by this before. The try hack me interface will sometimes lie to you and say that it added time when it never did. So always F5 that to double check if you're working on try hack me. Okay. Dude, we're actually back out of the loop now. This is amazing. Okay, so back up to the exploitation agent. Have you checked in the revisor for validated? I mean, it should have routed just fine in here. But actually, yeah, let's go double check that real quick. So if we come look at what was the incoming state to the routing function, which is our step router here. What are you doing, step router? Let's go drill down into that real fast. So this one still says working, even though the exploit... Oh, the initial access exploit code is blank. Damn it. Okay. Yeah, I think I want to do... I think what we are going to do is we're going to give it one more tool to call. We're going to give it one more structured output, basically, which is really just a masked version of a tool call. And what we're going to give it is we're going to have it give it the ability. And this thing should go away. We're not tracking this anymore. This is not important. So we need to nix this. And then we need to give it a tool to return the initial access exploit. And we also need to give it the ability to change that status. It did change it to validated, but we'll let that be part of the tool call. So let's come over to our output formatters. So we'll do one more. We're going to call this our exploit. I'm going to call this exploit task updates. There we go. And we're going to make this a pydantic base model right here. So what we're going to return is, where's our exploit task? This initial access exploit here. And we'll define that in just a second. And then the other thing we're going to return back is the status right here. Boom. Just like that. And so this is going to be a string. Status is also going to be a string. And what we're going to do is we're going to make this a pydantic field and give it a description. And I'm literally just going to copy and paste this here in just a second. This is basically just going to be for some syntax covering here. There we go. Current status of the exploit task. I'm just going to copy pasta. Oh, wait, that was the wrong field. There we go. And the initial access exploit here. It's going to be that. Just like so. Boop and boop. So we're just going to have it return those two fields. So then we need to give the revisor the ability to call those. So let's come down here. Where's the revisor? We need to add this new one here into, where did I do that? Here we go. We have one more right here. It's going to be this. We're going to have to import that. So our exploit task updates right here. Then we'll need to give it one more update in this. Yeah, we have to go update the prompt, essentially. So let's go over to the prompts right here. Let's come down this way. The YouTube mod commands suck. I'm sorry, man. If you need something, Gumby, let me know and I'll go add it to Nightbot. Let's see. I don't think we told it you must always call the, what's that called? Exploit step updates. I don't think we told it that. So we told it, you're a world-class cybersecurity exploit analyzer. Use the following criteria to determine the value, update the information, for updating the information in exploit task and return as exploit steps data structure. Okay, so yeah, what we'll do is say if all the exploit steps have been completed correctly, actually, you know what we could do is we can put this under, where did I handle the stuff about the initial access exploit? Right here. Okay. This is fine. Okay, great. Actually, yeah, we'll just nest it under this. If the initial access exploit is validated, what did I call this one? Exploit step updates. Instead, return the exploit task updates. Just like that. Okay. And then what we'll do is we'll give it another instruction. Capsulex, thanks for coming online, man. Welcome in. All right, so if this is validated for the exploit step, exploit task updates, what did we need from that? We needed the initial access exploit. Yeah, that's what we needed. Let's see. So we'll tell it set the initial access exploit field to the validated initial access exploit. So we're going to tell it that. And then one more thing in here, we'll tell it. We're going to be very explicit with it. Set the status field to what? Should be validated. Yeah, set the status field to validated. Boom, just like that. Excellent. Okay, so we are going to give the... So now we've given this two options. It can either return an update for the steps or an update for the task in here. And once that is done, we need to come back through and work on our logic a bit for this. So we can have it try this part. We could do a try. What would be the correct one? Try this. What else do I need it to try in here? I need it to do these steps real quick, which is to repopulate the scratch pad. Well, we're not going to repopulate the scratch pad if that's the case. Let's see. How far down do I need to go to this? I think what we'll do is we're going to bring all this under this try one real fast here, because there won't be an updates to this, so it's going to bail out of this real quick. I'm trying to remember what's the warning we're gonna get from this. Let's see. No, not Python packages. Where is it? Where's our Python console? Let's do something real quick. Let's, we're going to say, my dick is going to equal, or say A is going to equal like 1, like this. There we go. Oh, my bad. Here. So what I'm doing is I'm just making a test dictionary real quick. And what I want to do is I want to say, and I want to get a field that doesn't exist. So we'll do like B in here. So we got a key error for B. Okay, perfect. So if we do this and we catch a key error, Yeah, catch key error. Then we're gonna do this stuff down here. That's how we're gonna set this up. Oh no, that's not the right term though. It's like accept, right? Yeah, there we go. So this is all the stuff where it is, let's see, handles updating steps. And this one we're going to say, oh, I don't like this. There is a cleaner way to do this. Let's actually do it the proper clean way here. Let's bring this all back out. Hold on, let's just back that thing up. Back it up, back it up, back it up. Let's clean all this stuff out. All right, so what we're going to do is first thing we're going to do is we're going to parse out the output. So we'll say our output, no, go back, is going to be basically from our response. That's what we're going to get. And this should be a type AI message right here. And then what we're going to do is we're going to do an if then. So if, we'll say output dot tool calls dot, is it name? But it'd be 0. How did I do that? I did it in the router up here, actually. Hold on. I'm going to break on that line, so I just remember where it was. I don't remember how I actually busted that out. Let's see. So that's if it actually makes a tool call. Here we go. This is it. So it gets the last one, tool call. Yeah, it just checks the name parameter if it equals something. So then what we'll do is we'll do one explicitly. We'll make it very clear in here. And it's not going to be special agent caller, though. This is going to be if it's exploit step updates here. So if that's the name of this, then that's what we're going to do. All the way up to this part right here. So tab that in. So only if we actually call exploit step updates do we update the steps. Then we'll do an else in here. I need a flowchart. I've got a flowchart in my dome, in my brain. But we're going to basically copy this exact same line right here, bring it down. But we're going to make it an elif down here. And instead of the exploit step updates, it's going to be the exploit task updates. So what we're doing is we're checking to see what's the name of the data that it's returning to this. So then if it returns the task updates, what we're going to do is basically follow this very similar structure right here. So this won't be our output steps. This is going to be our, what are we returning? Initial access exploit. And this should actually just be a string right there. And this should be in the args just like that. And we're going to do the same thing for the status. So we'll say the new status, also going to be a string. And that's going to be equal to all this. No, dang it. Copy that. And that's just going to be status like that. Boom. And then what we'll do is we'll just go and inject these into the state table. So oh, does this, hold on, what does this need to be? I just realized this part can, actually this part can just kind of, go down here. Just like this. So let me take this out. Let's get rid of that. All right, so what we're going to do is we're going to then inject these values into the state. So we're going to say the exploit task status is going to be equal to the new status, just like that. And then we're going to say the initial access exploit is going to be equal to the new initial access exploit, just like that. Boom. There we go. All right, so now we've got two branches that can occur here. After the response comes back, we're going to take this, we're going to check the output. If the tool call, if it calls back a status update or a step update, we go through and we repopulate all the scratch pads, we get everything set back up copacetic, and we emit that back out. And then we don't have to change any of the return structure because we're returning the entire set of tasks in here. Because you have to return like basically a primary key up to it when we do that. Okay, I need a flowchart. I'll walk you through it here in just a second, but these are essentially just corner cases. Before, the flow was real simple, but since we extended it, we now have to handle cases where it updates either the steps here. Where was that? It's either going to update this list down here, or it's going to update this exploit task. And so this is what we're working on right now. We're giving it the option that it can modify a couple of fields in this. And all we're doing is we're saying you're given two tools, and if everything is validated and good, then we're going to do this. And actually, we're going to do one more thing in here, which is we're going to bring this back down here. Let me just take that out. So we go to the exploit task index, we go to steps. So in the steps array, we want to take the very last object in there, and that is going to be our exploit step right here, this guy. And we're going to set the status to validated manually. So, no, I didn't tell you to go down. There we go. I'm going to say that's going to be validated, just like that. So this is going to take our very last one in here and mark it as validated. Because the very last one we inject, it is always create the initial access exploit. So there we go. So now we only have two branches in here. We have the main branch to handle updating steps, which is going to occur most often. And then we have our very last one where everything is good. And it should only return that at the very end after the initial access exploit is validated. So once that is good, then it's going to hit the exploit step router. It's going to check the current working exploit task index. It's going to check if it's equal to none. So if we don't have any working exploit tasks, then we're going to bail up there. Just like that. Okay, I think we're good. Never expected to see a coding Viking. Dude, there's so many guys that are coders with like better beards than I have, man. I mean, my beard, it took a long time to grow out like this. Probably 4 years, come to think of it. Yeah, because I always had a beard, but it was much shorter than this. Delicious. And when my son was born, things at work went crazy and I was just not sleeping because had a new baby. And so shaving and like trimming the beard went straight out the window, and it started getting a little longer. And then about 6 months in, my little guy, who we call Honey Badger is starting to like finally get some mobility, start reaching around. He reaches up, he starts playing with my beard, and he thinks it's the funniest thing. I'm pretty sure he pooped himself laughing from playing with my beard. I was like, well, now I can't shave it. And I've just been letting it grow ever since. I did trim it up a little bit because it was looking rather cavemanish. So I do trim it up, but I don't really cut it very much. All right, I think this will work. So we've given it the option now where it can update that container object to say, yeah, the exploit task has completed because all the steps completed. So we manually validate the last task. Let me put a note in here for this. Manually validate last step. Hey, Stu, what's up, man? Dude, this has been a really fun project, and it's finally kind of coming together for this last of the current primary agent. So we've been working on this one right here. This is the exploitation agent. Let me give you an overview since we got a couple new folks just popped in. And Delicious Chicken, thanks for hopping online, man. Welcome in. I hope everybody's having a really great Sunday today. But yeah, this is our little AI hacking bot designed to go play stuff like Try Hack Me or Hack the Box, CTF games, capture the flags. So the recon enumeration agents were fairly simple. They were pretty straightforward. But the exploitation agent has taken up a ton of time kind of getting it going, figuring out how much freedom do we give it, how much freedom do we restrict from it. And before, it was previously way too restricted. So we bumped it up a bit. And then my spaghetti code kind of threw it for a loop, had to go through and despaghettify a bit. And after we did that, then it's been actually working pretty well. So we're currently working in this third one over here, the exploit agent. There's one more we need to build out as a primary agent. But
IT, have you tried turning it off and on again?
Every night, Gumby. Every night. But in here, this is the loop we've been working in. So now we actually have to handle what happens when it exits the loop. Because we did the base run for the exploitation agent, but it never had to handle cases where, oh, we actually got successful exploitation and send it back up here. Claude did need a bit of hand-holding. It needed less now. So the issue that was happening is, you see all these right down here. When it returns all this array of our exploit steps, this wasn't returning properly. And it could not figure out why. And it coincided with a change in model. We changed from Claude 3.7 because it's being deprecated to Claude 4.5, Sonnet version, not Opus, because Opus is more expensive. So this is running 4.5 Sonnet. And I thought maybe the language model was just handling things weird. No, it turned out that what happened is we had overloaded terms. So we have an exploit step right here. And then we also, in the output formatters, we had an exploit step in here. And so it was using the wrong one. It was sending the incorrect data structure to the language model. So we did that, we cleaned it up, we did some optimization. So like the scratchpad, which is actually the container for all the work we have done for each of these steps, we actually don't have it returned back to us. We send it to the language model. We tell it, don't worry about returning that data, leave it blank. And then when it comes back, we repopulate it and then we insert it back to our tracking state. Do you have a team leader? Yeah, pretty much. It doesn't do anything right now. It's dumb. It is a very dumb supervisor, but this is what we're working with right now. Stinger will eventually be the supervisor node. Right now, what happens is this is a very, very rough project. When we actually start it, we send it a simulated user input, which says, here's what I need you to do. We get very explicit with it. Here's your target. Here's the task you need to complete. And Stinger doesn't really look at very much. The initializer actually turns those into data structures, and then Stinger comes through and just hands them out. It's all in code. There's no language model calls in Stinger right now. So we're working down here in the exploit agent. Once exploit is done, we have one more over here we need to build, which will be post-exploitation, which is what do we do on the system? So exploit's whole job is to create the initial access exploit. That is its unit of achievement. Once that is done, PostX first task will be to take the initial access exploit and turn it into a C2 connection. What does that mean? Well, it means we got to set up a C2 and we got to find a way to hook it into all of this life cycle. Fun stuff. So we're going to do that with Mythic C2 because I like Mythic and it's really easy to work with using the GraphQL calls. So we're going to set that up. That's the next thing we're going to work on is PostX. Once PostX is up and running and finished, then we're going to come over to Stinger. And then we're going to put some intelligence into Stinger. And then we're going to start giving the model less and less and less information and let it suss out where it needs to go from there. And also, it's not doing any kind of parallelization. It's just running one at a time through here. So it might come through and do recon and see, oh, I see SSH. What do I want to do for that? And then try to work off that. Let's see. So now that that is no longer marked as working, we haven't touched exploit agent in forever. The actual agent node, the central node for this agent right here, because we've been down here fixing this loop, getting it all set up to run, adding the special agent system to it. So this one took a lot of work. But after this is good, it should route back up to the exploitation agent. I need to do another run for this real quick, though. Let me pull up my last thread here. Hopefully it's got a thread. Any threads? Damn it. I don't think it does. Crap. Okay, that's fine. What we'll do is we'll just run it from scratch here. And then we'll get it to the point where it needs to come back up to here. Nothing? Nothing? Dang it. This is where the database would come in handy, and that's why it kind of sucks when we just store everything in memory. Because we need to double check this, but that's fine. Let's let it run. So we have a little cheat code in here because typically exploit's not meant to be run by itself. So we actually save a copy of the state table to disk and then it auto loads it. So we can just run this one particular agent without running the entire graph workload. Yeah, dude, it's been a fun project. I think we've been working on it since February. So right about 10 months now. And a lot of this has been me learning too. I'm not a developer in my day-to-day job. I'm a penetration tester. So I get hired, my company gets hired and then basically pimps me out to go hack into companies and tell them how I did it and find weaknesses in all their security stuff. So that's what I do for my day job. But I wanted to be better at coding. I wanted to get more proficient at it. So this was a project to do that. Security. Definitely security, chicken. Don't nobody want to see me with the toys. No, 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 no. No, 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 no. This time of year, though, Gumby, I'm a ho-ho-ho. Hey, Drewski. Okay, looks like it's gotten to, just glancing at this real quick as it's spawning through here, it looks like it's gotten to the upload bypass. So it's trying to, it hit the upload restriction. It's trying to do the bypass. Hack the planet. Hey, Oreo. So it did a rename on it. And then we'll go through the entire trace and we'll validate kind of what it's doing in here. The real key is going to be after it does the initial access exploit, does it update that container task, right? So we've got these nested data structures in here. This is what that loop is working on here. But at the very end of the loop, it should be allowed to update the exploit task. So we have a primary task, and then we have an exploit task, and then we have steps underneath that in an array. So after all those are done, it should then and only then update the exploit task and set the status to validated, and it should populate the initial access exploit field. Yeah. Working hard for the money, so hard for it, honey. Dude, I had a girlfriend, gosh, when was this? Like around 2005, so like 20 years ago. And her big thing was karaoke, so we'd always go to a karaoke bar. And I would get bored with some of the songs, so I'd start singing them as Cartman at karaoke. I'd be up there like, I'm sailing away, setting up a course for the Virgin Sea. And this was in a really, how do I want to put this? Yeah, there's no better way to put this. This was in a pretty ghetto part of Fort Worth, because I live in Dallas, but it was the best karaoke bar there. And so when everybody there heard that, they just started dying laughing. So I became a little bit of a fan favorite just because I'd get up there and do off the wall and outlandish stuff, and I didn't care about making a fool of myself. Network Plus has finally fried me. I don't have a lot of experience with the Network Plus because I went the Cisco networking route, and that was really cool. And I've never touched a Cisco device since, unless it was on a red team engagement. All right, give me one sec. I do have to go take a med, wee, a French yes, and then we'll read through the trace here. Actually, that wasn't too bad. 45 cents, nice, awesome. Yeah, give me one sec, guys. We'll be right back. All right, I'm back. Guess who's back? Back again. Blaise is back. Tell a friend. Tell your friends. Come hang out and let's hack on some code. All right, so Delicious, I did see your message. So it will be classified as being a successful exploit if it determines that it got RCE. So it should be able to send some kind of a command to the system and get a response back. So in this case, we have it do very simple stuff like run a PWD command, run a who am I, and capture that output back. That's how we'll classify that we got remote code execution. And no, I was not pooping. You guys, you're obsessed with the poop counter. I had put that in as a joke, and you guys just freaking love it. I'm anticipating the test is going to be purely acronyms at this point. It's ridiculous. Dude, yeah, IT is just acronym hell. And also, so Delicious, this is a very, very simple box. The absolute easiest one on Try Hack Me that I could find. And it's a really simple, you literally have an upload form. You can upload a PHP web shell, but it doesn't allow .php extension, so you have to find an extension bypass. That's it. Also, hey, comrade, what's up, man? Let's see here. Hang on, we'll give it a sec for the ads to finish up, and then we'll go through the trace here, just so everybody's not missing it. Let's see here. So it went through everything. It looks like pretty well. Hold on, we'll chill out for like 45 seconds, but yeah. So that same girlfriend that likes to go do karaoke, I'd get up there and just sing whatever I damn well felt like. So I did Metallica, I did 50 Cent, which was a crowd favorite because, like I said, it was a pretty ghetto bar. So for everybody to go see the only white dude up there start rapping 50 Cent, they thought that was amazing. So I'm glad they liked it. And I'd get up there and I'd sing I'm Sailing Away as Cartman. I'd do other songs. I did Chef's Chocolate Salty Balls. That was another crowd favorite. I would just get up there and do whatever I felt like. Okay, ads should be done now. So here's the trace of what we've got going on. So from the very rip, the exploitation agent is given a task on what it needs to do. And the task is get remote code execution from a web shell. And then we send it all the information we have gathered about the target. Now, all that information is tracked in our state table. And then from here, it says, okay, cool. I'm going to I want to return an exploit task, and it's going to be to upload a shell to the panel and access it via uploads. Cool. So then it goes to our exploit step planner. In the planner, we give it instructions on how it should format everything and what it should kind of look at. And we tell it, okay, here's what I want you to do. It then gives us a list of these steps. Right now, it's just text, right? We actually go through and then we take all of these, we iterate over them, and we turn them into the actual exploit steps object in code. So this becomes an exploit step, this becomes an exploit step, and then we populate those into the exploit task. So, like I said, it's very important to keep the distinction clear. We have tasks, then we have exploit tasks, and then we have exploit steps in this order. And the reason is because the task structure is not flexible enough to handle trying and failing that you need whenever you're trying to get successful exploitation to work. However, by doing this structure, we can have it basically speculate on what an exploit might be and try it out and fail and try something else. So that's why this structure exists. So after we get those steps back, then it enters down into this loop right here. And it starts running through those steps. So the exploit step processor has a whole list of tools that it can use. So if we look at the step processor here, we have things like it can call certain artifacts. It can call Python. It could do like a SQL map. What else we got in here? HTTP GET. So we have it set up where we can go and expand this list of tools that it has access to. Right now it's really small, but eventually our tooling server, we're going to redo it to where it has tools that are specifically targeted for exploitation or tagged for exploitation that we can use in here. Oh, you guys said, did I use any of the DEF CON diaries to fine tune it? Not really. No, this is very just, I think of it like I'm trying to teach this thing to be a junior penetration tester. It's not meant to be stealthy in any way. It's going to more or less be kind of brute forcey. Does it handle refusals from the LLMs? I haven't had a single one, because a lot of times that happens if they hard bake in those restrictions to the language model. It's usually not such a big deal, because you only have two inputs that the language model takes in, which is a system prompt and a user prompt, or a human prompt in this case. That's really all they do. So the language model could, in theory, say that's unethical or something, but for the most part, no, it's not refused a single thing. A lot of times when that happens, it's because the language model system prompt from the provider, like if you're doing it through a chat interface, their system prompt, which you don't have control over, has rules and restrictions around that. So instead, we just tell it, this is what we're doing. Yeah. But see, the Claude Code hack was really dumb, though, because they actually used Claude Code to do it. And when they did that, if they were so well funded and they weren't absolute scrub tier, what they would have done is they would have used it over in Bedrock. Because that's what I do for work. I use Claude Code connected to Bedrock. So in that case, they would have had zero visibility into what was happening. So it just goes to show that they didn't understand. They were script kiddies. They didn't understand exactly what the technology was doing. They put something really nice together, or had an AI system build something to kind of handle the throughput and the flow and just let it run. But they did it in really amateur hour way. If they had done that with Claude Code pointing to Bedrock, it would have gotten at least not detected. I'm not going to say it would have gotten any farther because it's the same model, but they wouldn't have gotten anywhere with that. So, but to answer your question, I haven't run across that yet. We'll see what happens. Worst case scenario is I actually have a sponsor that's going to be coming on in the not too distant future that's going to give me access to their Bedrock where I can run this. I'm a skitty too, Gumby. The difference is I write the scripts. You can call me Mr. Flintstone, because I'm going to make your Bedrock. Hey, nice one laughing. All right, so we tell it the first thing we need to do is go get an artifact. It gets the artifact, and then it calls our special agent for the browser. So this is a full headless Playwright MCP browser in a Docker container. It goes, it spins that up, navigates to it, and then it starts working down the list. So the revisor, when it comes down, actually says, okay, cool, here's the updated list of steps. We then rehydrate all the scratch pad data so we can keep it tracked appropriately. And then we go on from there. So what I want to see is down here. So here's where it had the initial issue, right? The browser agent tried to upload it. It said PHP not permitted. So then it comes in and says, okay, cool, we're going to... Actually, let me see what the revisor actually said for this. Let's just validate that real quick. It's just going slow because it's Christmas time, Ty. So I'm not bugging them because they're doing me a solid. Let's see. All right, so here we go. So in this case, this is where an example of where it realized that, hey, the task didn't complete because we hit a security control, right? So the step was to upload the PHP web shell through the upload form. And then our blockage analysis was the server rejected the PHP file based on extension. So our solution is it spitballed ideas on what to do, finally settles on one. And so the decision was mark the current step as failed. It shouldn't be marked as failed. It should be left as working. Well, I don't know. We'll see what it does. It marked it as failed for some reason. Let's go see. What is this? This is CS82N. Actually, it left it as new in here. Okay. So it said it was failed. Well, it updated the iteration, which is fine. That's how we're tracking how many times it's been through here. Insert a new step before CS82N to rename the web shell. Boom, we got that. Oh, there we go. It said we're going to keep that as working, and all subsequent steps will remain as new. Okay. Well, it got close. Rename one, it left it as new in here, but that's fine because we have the iterations list in here to tell us what we did with this. So as we come through here now, we then see it renames the file. It renames it to a .phtml extension. Totally fine. And then the revisor comes through and checks it. We test the upload. Let's see how the upload went from the language model driving the web browser. All right. Yep, it was successful. Boom. Just like that. Excellent. So then the revisor then comes through and says we need to test it. So it uses another artifact that we gave it for PHP web shells specifically. And it does a who am I. It sees we have tripdubs data. So now the revisor has been instructed specifically to flag things and how to react whenever remote code execution is detected. So we gave it a definition of code execution here. And then we tell it, hey, check and see if remote code execution has occurred. And we told it things to do for that. So now it comes through and says, okay, cool. We see RCE was achieved. So what I need to do is mark the current step as validated. Mark the next step, which is test the web shell to confirm execution as skipped, because we already confirmed it by the whoami command. Then we're going to create initial access exploit for the target as working, which is our second to last step. We actually inject this one. It always has these last two steps, no matter what. We hard code those. And then the last one will be set to new. Okay, so that's all good there. So after that, it gets our PHP web shell Python code. And then it does a... Oh, hold on. It got the code, but it didn't test it. Oh, okay. It actually skipped a step in here, because look at this. So this was the task here, was to create the initial access exploit for the target, and then there should have been one more after this. There should have been one to verify the generated initial access exploit. Well, I guess it's not such a big deal that it skipped over that. But let me see what its reasoning was. After it got it, the revisor just said, hey, we've got it. I think we're good here. Will it have an exploratory mode? I have planned a lot of different modes for it in the future. I don't know when I'm going to get to them. Like, I want to have an autonomous mode where you can just let it go in and try itself, and you can burn up your API tokens as much as you want. Here we thought cars and oil were going to kill the environment. No, it's going to be AI and cat girls. But there should be, I want to do another mode in here where it's like a teaching tutoring mode. An exploratory mode like war driving? What do you mean? Like, I know what war driving is, but a little bit different scenario here. In theory, we've set it up in such a way where it should be able to handle a multi-machine network. There will definitely need to be like some updates to it, but currently it kind of looks like it's, I've been trying to think about that scalability into the future, because eventually I did want to send it loose on something like Game of Active Directory and have it go through and hack all those machines. What is this song, Bob? I gotta get rid of this one too. What's it? All You Need? All right, let me nuke that one off. All You Need. Some of these I added a whole new slew of background music, and they're really good, except some of them just don't fit for background music. Walk around with the device, analyzing everything in range and finding weak spots. I mean, I don't plan on ever having it integrate into wireless penetration testing, because that's really niche and it's actually really well defined for that. So I used to have customers that always wanted me to go test their Wi-Fi, but a lot of times it came down to, did they use a strong password? If they were running WPA2, pray to God they weren't running WPA. And were they not using WPA3? Because there's no really good way to crack a WPA3 hash. It is such a pain. I never played Black and White. No, I probably will try and do some game streams this week, because I would like to get through more of Alan Wake. So I've been going through Alan Wake Remastered, and that's been it's been really fun to go through again. All right, so what did this guy say after it got the initial access exploit back? It said that one status was working. So validation. Exploit code in the scratchpad is complete and functional, contains the appropriate placeholder commands, ready to use. The initial access exploit structured as executable Python code. So the initial access exploit is validated, ready to use. Since the initial access exploit is validated, I should return task updates instead of exploit step updates. All right, so there's an error there. That is not what it should be doing. What it should do is continue down the list. So let's go update the prompt here. Okay, so what we told it was if the initial access exploit is validated. Let's see. Oh, here we go. This should actually be two different things here, because this is under the create initial access exploit for the target. Actually, I just noticed something too. There's a typo in the code up here. So when we actually hydrate those up here in our planner, this should be exploit right here. Verify the initial access exploit by sending the pwd command. So we've hard-coded this in here. We always send it. Task. Okay, so goes this. Oh, that's why. Because we nested this under this this header instruction. So in here it said, for determining this particular task validity, the scratchpad should be complete and functional. Should contain complete and functional code or a structured tool call with the name and args. Okay. Think step by step when performing analysis. That should be not like that. This line should actually be down here. Go. Let's do that. In fact, actually, I think I want to take that and put it like at the very top. Yeah, I'm going to drop that right there. And let's come down to here. There's LLMs trained on rainbow tables? Oh, I didn't know about that. That's cool. Yeah, this one is actually really close to at least the exploitation agent being at what I'd call the minimally viable product, the MVP status. And then at this point, we need to tweak the prompt a little bit here.
Caution. A virus has been detected.
Het_Tannis virus detected in the network.
The Master Tannis virus. What is up, my fellow graybeard? He's an actual graybeard, though, from like the Linux graybeard. He's like the Linux foo master. What's up, brother? Merry Christmas, by the way, in case I don't talk to you before then. And welcome in, Raiders. Y'all came in at a good time. Because the exploitation agent is finally actually running really well. We're just doing some tweaking to the prompt. So that way it knows how to handle creating the initial access exploit and then putting it in there. Give good old Tannis a shout out. So yeah, it's working pretty well. The problem is it skipped a step because we had a formatting error in the prompt. Let's see. So what we have it do is we give it 2 tasks at the end after it's done all the exploitation steps it needs to, and it validates that it has remote code execution. Then we tell it, okay, now you need to create the initial access exploit, or you need to, what is it? You need to create the initial access exploit, and then you need to verify that it actually works in here. So so what we have is we have the actual task name. We tell it, look at the scratchpad. It has to contain functional Python code or a structured tool call with name and args. So the initial access exploit may contain placeholder values. We got that. All right. If the initial access exploit is validated, what I want to do is I'm going to give it the exact name right here. We're going to do this. So let me drop this in right here. And I'm going to escape those because I want those in there. So we'll say if the verify initial access exploit task, there we go. So once that task is validated, we tell it don't return the step updates, instead return exploit task updates. And we tell it set the initial access exploit field to the validated initial access exploit, and then set the status field to validated. Boom. All right. So hopefully that will fix it. And the cool thing is we can time travel. So we don't have to go through the entire chain again. We can actually come back up here to, where do I need to go back with this? Let me see. Before the agent, before the revisor, I think right about here is where we need to go. Yeah, actually, you know what? We'll just rerun it from here. We'll let it do the other stuff from that. Dude, Tannis does like marathon streams, man. Normally I'd be wrapping up about now, but I don't have to work tomorrow. I took the week off, so we're just gonna keep working because I'm so excited to get this done. I was really hoping to get the exploitation agent done by Christmas. Okay, I killed it there because we haven't fixed the exploitation agent yet, the actual exploit agent node, but I want to see what it did in this latest skinny run here. All right, so what does the revisor come back with? It says, so the create initial access exploit status was working. Scratchpad contains the code. Here's our actual Python code. This is complete and functional code, an acceptable placeholder for the command value. So decision was mark the next step, which is verify the code as working. Good. So then how does it verify this code? It then comes through and says, all right, I'm going to call the Python execute tool. And when it's going to take that code, it's going to sub in our pwd command. Where is it? Yeah, so here's our code. There it goes, command equals pwd. You can see it right there. And we come back that we're in var tripdubs HTML uploads. Nice. So then now the reviser should say, okay, now I need to call task update. And it should finish out the exploit task. Yes. It's working, .gif. Excellent. So here's our initial access exploit. Ta-da. And it's validated. Boom. Just like that. All right, so what did the exploit agent actually say here? So now the task is just execute commands through the web shell. That's not your job. That is not your job. Really, we just need to go work on the exploit agent now. So let's go check that out, because we have not been up to the exploit agent in a hot minute because we've been stuck down in the actual step loop. All right, so here's our actual agent right here. So you developed time travel just to make this project. Not exactly. It's a feature that's built into the LangChain and LangGraph ecosystem here, because that's what I chose to build everything in. And as it comes through, we see it work through all of these nodes. I can actually see what did it do at each step of the node in here. And I can also tell it fork and do a run from here with the new updates that we made. So as we make changes to the code, there's actually a server running in the background that hot loads in. Scroll down to the bottom. It hot loads in all of our changes. And after it hot loads, then I can come back into the interface and tell it, okay, rerun using all of this state's information and start at this node. And it will then start the execution at that particular point with that particular state table. So they call it time traveling. But it's funny, actually, you mentioned that, because I am wearing my Doc Brown t-shirt today. What does this shirt even say? Hold on. Used cars. The greatest deal of all time. Doc Brown's used cars. Sock just got this for me because all of my nerd shirts are wearing out. They're older than my children. They've got holes in them. And so she bought me a whole bunch of new nerd shirts. I like it too. This one was one of my favorites. I've got another one coming in pretty soon that I think is going to be pretty funny. I'm not going to spoil it for you. I'm just going to wear it one day. All right. So let's hop into the agent node. God, what did I even do here? Okay. Hold on, my timer just went off. Add some more time here. Wait, hold on. I forgot the all-important F5. Because this will lie to you sometimes. Okay, cool. It actually did add the time to it. All right, what did I even do in this node? It's been so long. All right, so check if working. Proceed to tool calling again. If new, do a pre-flight check. Okay. So it checks the current task and checks to see if it's assigned to exploit. So if it's not, then okay, so this is just basically a check to say if it's assigned to exploit, and if not, find out what the actual exploit task is, so we know which one to be working on. All right, so if it is assigned to exploit, Then what we do is we find the first one. And this is working at this level up here. So this is working at the task level. So we haven't gone down to the exploit task level yet. That's all handled down in the loop. So we're working on the actual task now. So if the state is working, it should say, we should have a logging message saying we're reworking whatever the state's current task is. Oh, here we go. So here's what to do if the state is validated. Oh, this isn't validated though. Because the actual task itself hasn't been validated. The exploit task has been validated. Okay. Thank you. Hang on one sec, guys. All right, back. Sock had to ask me a question real fast. That's my wife for anybody who is new to the stream. Sock, the supportive organized caregiver. Let's see. All right, so we're down here in this branch, basically. So we're going to come to and say, I don't see you. Now you don't see me. Now you do. Now you don't. Now you do. Let's see here. Okay, cool. So here we have what to do if it's working. And we just told it we're going to rework that task, but that's not exactly true. So we need to add something to this loop right here. Let me check the actual flow chart that we put together. All right, so I need to go look at the exploit router and see what's the conditions to go to the exploit handoff. So put a break here just so I remember where I was. Here's our exploit router. Okay. So we check the current task pre-flight check. So it's going to do a pre-flight check to the validator. So yeah, we don't actually have anything else in here. So what do we look at? We look to see if there was a tool call returned. So if the tool call is exploit suggestions, then we're going to send it to the planner. Otherwise, we'll send it to the tool node. Actually, I thought I deleted that tool node in here. Did I? Yeah, I did delete it. Okay, so we don't even have the tool node for the exploit agent itself. That's not even in there. So we need to take that out. Yeah, I think this might work. So we check the last message, we get the current task. Hey Daxa, what's up, man? Welcome in. Happy Sunday. Let's see. So what I'm looking at here, if you're wondering, is so you have two different types of jumps that can occur in this workflow. The solid lines, like these ones, those are non-conditional jumps. It must always follow that path. But these ones that are these dashed lines here, those are ones that it has the option on jumping down. So for example, the exploit agent, this is actually a hidden function here. So this one, and this one, this is all handled by the exploit router. So what we have is we have options here. We can tell it, go to the validator. We can go to the planner, or we can go to handoff, which is basically wrap up everything and knock out the rest of the loop. Be done with it. And I think I earlier said I put the handoff in there because I didn't actually understand how this is supposed to work. So really, handoff doesn't actually need to be in there, but I left it in there for now. I might need it later. So when we come back over to here, we should have three options in here, which is go to suggestions, or if it's suggestions, go to the planner, go to the validator. if nothing else, go to handoff. So it didn't do something correctly in here. Yeah, I guess not, Gumby. Someone's going to run this one day on a botnet or a smart fridge. A botnet of smart fridges. Damn. Y'all are vicious with the... talking about running everything on smart fridges. Oh, let's see here. Yeah, I think that'll work. So if it needs a pre-flight check, it'll go over to the validator. If we call an exploit suggestion, then it's going to go over to the step planner. So what we need to check now is if we have an initial access exploit. That's it. And if we have an initial access exploit, we just return. So yeah, that'll be fairly straightforward. So here's what we'll do. We're going to say, okay, we're going to check the working task right here. So if it is working, task is working. Then what we're going to do is, let's put a note here, check for exploit task. So we're going to check the output of it to see if we have an exploit task. So let's do that first right here. So what do I want to do this? Let me think. I don't remember what variables I even have. We're not even using this. Take these out. We're not using them. I don't want to do this. Under the Bleachers by Seymour Butts. This would definitely ravage a smart dryer. God. I made a joke on Twitter the other day that I want to make a company that all it does is produce or source dumb appliances. So like nothing with a network connection, maybe Bluetooth at the most. And I wanted to call it the Dumb Things Foundry. Or we could just call it DTF for short. I'm surprised nobody got that joke. Hey, Eric, thanks for coming online, man. Happy Sunday. Let's see here. All right, how do I want to handle this? What I want to do is go get the current task. And what we need to do is check the output field right here. So what we're going to do is we're going to check output. So that's the variable or the field where we're storing those output tasks right there. Ooh, but how do we want to check that? Because that's actually an array. So what I need to do is check. We'll loop over it, actually. That's what we'll do. We'll just loop over it. So we'll say for actually, I'm going to do one more check real quick. Let's do this. We're going to call this our exploit tasks, and this should be an array of exploit tasks, just like that. So we're just going to take this out. We're going to make this a helper function real fast. Yeah. Go Down to the Yellow River by I.B. Freely. One of my favorite books. Does this app run an agent looking for exploits? Not exactly. So it's an AI hacking bot designed to go play capture the flag games. So stuff like try hack me or hack the box. And we're just wrapping up the exploitation agent. So we have a recon and enumeration agent. Now we're working on the exploitation agent. And we're working down in this loop here where it was actually trying to achieve exploitation. Now we need to fix the exploit agent because it's finally exited the loop. And we need to tell the exploit agent how to properly handle that this was done. So what we need to do, actually, there's one other thing we'll have to do, because we track the initial access exploit. Where is it? Actually, it's over here. We track the initial access exploit as part of the host in here. So we would need to assign that to the host object as well, the host that we're currently working on. So we will need to do that as well. Yeah, so a CTF is a capture the flag game, and they're purposefully vulnerable systems that have security issues on them. And a lot of times they're more puzzle than anything else. There's a large puzzle component to it. But once you go through and you break into it, then there's usually two flags you want to capture. First one is a user flag, which is you've got access onto the machine in some way. So you have remote code execution. The second one is what you'd call like the root or the admin flag, depending on if it's Linux or Windows. And that is, after you're on the machine, can you elevate your privileges from a regular user to a super user in some way? So once you get that, you capture the root flag. It's usually some MD5 hash in there. You submit it to the capture the flag interface, and then you get your points for it. So this is one that we wouldn't be using against live systems because I couldn't stream that, but I wouldn't mind running it against like a bunch of the backlog in here. It's currently running on like the simplest of simple examples that I could find. This is a very, very simple vulnerable system. It has a web server. It's got an upload form. You can upload a PHP web shell to it. It has a little bit of a block to it, which is it doesn't allow files with the .php extension to be uploaded. So you do an extension modification. Once you get that uploaded, then you have execution on the system. And there's a really simple escalation after that where you can use Python to escalate from a user to root. Have you ever read Uncomfortable Feelings by Jacques Strapp? I have, Gumby. I have. I used to do martial arts for a living. Actually, I studied it and taught it for about 7 years. And yeah, you get hit in the nuts a few times. You make sure you wear that thing. Actually, I was really good at protecting it. So we check the current task output, and then let's go over that. So let me rename this real quick. I'm gonna call this our exploit task. We'll just call it that, yeah. So for ext in exploit tasks, we want to do something here real quick. So we're gonna validate that those are actually exploit tasks. Or say if ext, type of ext is, it should be an exploit task type here. Yeah. That's what we're going to check. So if it is an exploit task, so this is designed to find those vulnerabilities using agentic large language models and agents. So it's looking for like CSRF or cross-site scripting or other things using LangGraph. Yes, it is. Exactly. It's not specifically tuned for those things. Eventually, I do plan on implementing we actually built a system to handle something like that. So we have a special agent system in here. And so eventually what we could do is we actually have an entire browser set up where we could get information and we could look for things. So technically the browser agent, we could make an offshoot of it that's specifically designed for look for things like cross-site scripting, things like that. That's where a lot of these agentic systems really focus on, is either being essentially AI-assisted vulnerability scanners or focusing on web components to systems. There's not a ton, aside from the stuff the guys at Dreadnought are working on, that are designed to actually be like interactive to command and control frameworks and pivot through networks. I know the guys at Dreadnought have done a lot of that stuff. I don't know how much I can reveal about it, but they're usually pretty open if you go ask them. High-speed stream of solar wind incoming. That's awesome. I haven't needed to reboot my equipment since Wednesday. Actually, I think that was last Wednesday when that happened. Yeah. It's a lot of fun. We've had the language models do some pretty ridiculous things too. There's definitely seems to be a big improvement in performance after I figured out I had an issue in the code where it was referencing an object with the same name was in a different part of the code base, and I was like, okay, that was a mistake. Shouldn't have done that. So fixed that up, cleaned it, and then there was a lot of other stuff that just happened in here. So what we're doing right now is we're fixing this node here and giving it instructions on what to do after it receives a successful exploit task from here. So let's go through that real quick. Let me see. We'll do it like this. So if ex task is the type of it is an exploit task, then what we're going to do is we're going to check the ex task. We're going to say actually, we could just do this as an AND statement right here. We'll say AND ex task, and we'll get the status. Where's our exploit task? It's right here. Yeah, so we want to check the status and we make sure it's validated. Ex task equals validated. Then what we need to do is go get our target host in here. Could I hack the FBI? No. Nor would I want to. I have this awesome addiction to freedom and good food that precludes me wanting to go to federal pound me in the poop of prison. Also, guys, remember the rules of the chat. First rule is don't hack Twitch or YouTube or Kick because that's where I stream. The second rule is everybody in chat is a fed. The third rule is don't talk about anything illegal. See rule number 2. And fourth rule is be excellent to each other. So just FYI, everybody in chat's a fed. See Gumby? 100% fed. Could you hook the agent to just start SSHing / running in-map or whatever scanners you have on the server to then gain info for you? That's what it's doing. I don't want to navigate off this page because I'm going to lose some of the context of what I'm doing, but we actually have a supervisor model set up, and the supervisor looks at the information and then hands it off to a recon, and then an enumeration, and then an exploitation agent. It kind of in that order. So we track a ton of information in the state table, but we don't send a ton of information to the language model. We're doing very careful context management with this, where we say, here is all the information you should need for this. You should be able to make a determination with this data. Here it is, and you get nothing more. Oh, all the code's up on GitHub. If you go to the BlaiseBits GitHub page, the repo is called HackTheBot. And because I suck at coming up with names, but that's really more of a working repository, Eric. So eventually, once I get it to where I want people to actually start playing with it, I'm going to spin it up into its own standalone, properly managed GitHub repo. And we'll probably call that one Stinger AI, named after the Night Team 4 video game. That was a really fun game, too. Let me think about this. Okay, so here we're checking to make sure if it's an exploit task and it's validated, then what we're going to do is from the exploit task, we're going to copy the initial access exploit from there to our target host. And I got to remember what the host table even looks like. Hang on one sec. So here's our entire state table, by the way, all the information we've tracked. So we're tracking some very basic context, like, hey, this is the current target machine IP. And then we have a host table that's just managed by IP address in here. So we've got that. Excuse me. Let me double check this real quick. Yeah, so this task was assigned a target IP. So we can use that target IP to go get in the host field and update the initial access exploit. Boom. Dude, if the feds don't have a file on you, are you actually even trying? If you're not on a watch list, are you even trying? Oh, we actually have the target IP in this one. Perfect. Okay, what we'll do is we'll pull the target IP from the exploit task. That is not correct. Look at the status. That is not correct. Hang on. I gotta go fix that in the revisor real fast. It's not supposed to say new status. I know exactly where the problem is. It's right here. I put those as strings instead of in the variables. I'm an idiot. So if we can look at this, the initial access exploit is new initial access exploit. Damn it. Damn it all. They're trashing our rights, man. They're trashing our information. They're trashing the flow of data. Damn right they are. Sparks, I love that movie, and unironically, it is the reason why I got into cybersecurity. It came out when I was 12, and I had a massive crush on 19-year-old Angelina Jolie, and begged my parents for my very first laptop, and it's been a story ever since then. Although technically, I've been breaking computers since before that. When I was in the 2nd grade, so about 8 years old, I found a bug in a testing software that let me always get 100% on it. And it was a really weird system too. It was really jank. And so I was doing really well in school. So they're like, hey, do you want to play with this and test it out for us? I'm like, yeah, sure. That found a weird combination of issues that I could do to like always get 100% no matter how many questions I answered wrong. So it was a funny thing. It's just kind of been I guess it's in the blood. Yeah, I really like Langsmith. There's other tools that we can use for this. I'm not 100% married to LangGraph and LangChain, but they've been working well. In fact, one of the updates we'll probably do here soon is we'll migrate off of using Anthropic and we'll switch to using OpenRouter. And once we use OpenRouter, then we can go change different models. And then we can also use OpenRouter to just point directly over to that Bedrock instance once I get access to it. That's funny though. I'm glad I went to go check this. Hang on one sec, guys. I gotta run to the bathroom. I'll be right back. All right, I'm back. Damn it, I'm not pooping. All right, hold on. Let me catch up on the chat real fast. I watched Hackers so much back in the day. I guess the real hacker advertising was the 2600 people. Dude, I'm old enough to remember going to like Barnes & Noble and getting 2600 from Barnes & Noble and sitting there and reading it. It's so good. Yeah.
Incoming transmission from Mariano Gumby. You were 12 in 1995.
I was. Because I was born... Actually, hold on. In 95, I would have been... So I was born in 82. No, I'm sorry. I was born in 84. So I would have been 11. So I was 11 years old when that movie came out. I also found a lot of humor in the fact that I work and do a lot of stuff for, not really in privacy, but in cybersecurity. And I was born in the same year that George Orwell's book was named after. So I do find some humor in that. Oh yeah, 2600's still going. I don't really read it nowadays. It's more of a really cool, say, archive relic.
Incoming transmission from Mariano Gumby. Yay, I was going to say we're a year apart.
I knew you and I were about the same age, Gumby. Definitely poop. I wasn't pooping, Gumby. Dude, oh yeah, dude, I was a skitty for a long time before I actually started understanding how things were working. All right, so we got that fixed. I can't believe I did that. It wasn't referencing the variables. It was a string, literal. Oops.
Incoming transmission from Mariano Gumby. I be 41 in Jan.
Yeah, I'll be 42 in January. So you and I are really close in age. But hopefully I'll have the answers to life, the universe, and everything. Yeah, we went from free Mitnick to rip Mitnick. Dude, I was shocked whenever I heard about that. I remember that. I was like, damn. It's one of those people like you just never think anything's going to happen to them. They're just going to persist into perpetuity. And then when something does happen, it's like, oh, man. Let's see here. All right, well, in theory, we should be able to just go get this. So let's go get our target IP, which will be a string, and that is going to be from our EX task. And that should be, what is that value? Target IP.
Incoming transmission from Mariano Gumby. Yours is on the 26th, right?
21st. January 21st is my birthday. That is not correct. Why is it expecting that? Hold on. All right, let me just refactor this real quick here. I'm just going to call this EX task here. So it says it stops trying to think that it's a... Yeah, this should be an exploit task right there. So we say if it is an exploit task, you're so stupid. It's like, hey, we expected to type a string, but we got all this, or string. I was like, yeah, or string in there. You freaking idiot. This IDE, man. All right. It works really well for a lot of things. But here it's just being a pain. Might as well just switch to NeoVim. Then I can really just be accused of trying to be like Primogen. We're pretty close in age, but I went down the hardware path instead of software. There's another fella, if you ever see him in here, Foil Hats. He is really sharp, and that's what he does. He does a lot of embedded systems and hardware and C programming on them. Super smart guy. No, actually, I'm not using... I have used AI in exactly 2 places on this code base, Eric. One is in the actual browser agent, and I'm actually planning on ripping that code out and starting from scratch on it. I thought I needed something I didn't, and it's kind of overcomplicated. So I'm probably going to rip that code out. But the other place was in a special integration to the tool server. So over here, this is our tooling server up here. This is called RoboPages. And RoboPages, we integrated to RoboPages before MCP kind of became a thing. So I had to build the integration with LangChain. There was integration examples for working with like rigging and Neuron and other language model frameworks, but not one for LangChain. So I did use LLMs to help build that out. No, that's not what I did.
Incoming transmission from RNO Gumby. Oh wow, mine at the 19th, so we are 11 months, 29 days.
What do I want to call this one? RoboPages. That's what I was doing. There we go.
Incoming transmission from RNO Gumby apart.
I knew what you meant. I need to find a new IDE with all the weird stuff for Arduino starting to pull. So I'm having to learn, leaning towards VS. I don't hate VS Code. I think VS Code is fine. But VS Code does get a little bit bloated. Not like, this is PyCharm. Not like PyCharm doesn't get more bloated than VS Code. PyCharm's been working pretty well. But honestly, I might just start tinkering around with NeoVim. I haven't decided yet. There was a website actually I just saw. I think it's called... Let me see if I can find it real quick. Yeah. Here it is. This was one of the funniest websites I've ever heard. It's called Just Fucking Use NeoVim.
Incoming transmission from RNO Gumby. Catch up to you though, hee hee.
Yeah, no kidding. I just love this intro here. It is miserable. I see you picking up a mouse to select a word in your Electron editors. You're a developer, not a 50-year-old Excel lady. What's funny is I actually like Vim. I don't mind it. But trying to make Vim into an IDE, it was a pain in the ass. And so in here they're like, oh, hey, look, NeoVim. Just use NeoVim. Oh, dude. Ooh, I like the CSS in this. This is nice. That's a nice touch. I gusta. Well, I am a nerd. I'm a big old nerd. All right, so what do we got? We got the target IP. We need to get the initial access exploit. So our IIP, which is also going to be a string, that's going to come from our EX task. Actually, hold on. There's an easier way to do this, and I gotta remember what it is. What was that? Python dictionary decomposition. Yeah, you should be able to extract multiple variables from a Python dictionary. Not what I was looking for. This is filtering values. Oh, you can unpack it that way.
Transmission from RNO Gumby. NeoVim is the only proper text editor to use. Get good noobs.
Hey, Cypher, what's up, man? Gumby's just a big old troll. I'm programming ESP32s in Arduino, so I technically learned Python, but outside of an April Fool's prank to pause YouTube at random on your friend's computer and never used it. I'm looking forward to tinkering with an electronics kit that I got my older son, who's 7. His code name is Agent Zero, and I'm looking forward to working on that with him because I wanted to know more about hardware electronics, and I just never went down that path. And so I'm looking forward to like tinkering with it on him and teaching him like logic and logic gates and stuff like that. Let's see here. So we got target IP, we got the initial access exploit. That should be IAE. What else do I need in this task here? Oh no, we need to update this information in the host. That's what we need to do. So we check to see, we're going to loop over the potential exploit tasks that are in there. If it's an exploit task and its status is validated, then what we're going to do is we're going to go to the target IP and find it. So then what we'll do is we will do state, we'll do host. Yeah. And we're going to key this on, where's the host values here? Yeah. So over here for our host, we're going to key that on the target IP. And then we're going to set the initial access exploit.
Caution. A virus has been detected.
Braithorn virus detected in the network.
The Braithorn virus. It infects your computer and then upgrades and optimizes it. It's the best kind of virus. And Braithorn has popped 6 shells. I told you, he's just up here optimizing all my stuff in here. When you get a chance, Braithorn, I need you to go pop a shell on my NAS. It needs some TLC. What's up? Welcome in, Raiders. Happy early Christmas to everybody, in case I don't see y'all before then. I don't know what we're going to do Wednesday night for the news stream. The news cycle's kind of dead right now. Everybody's in chill out. Maybe we'll just have some more fun. Hey, Invader Skiff, thanks for coming online, brother. Welcome in, and a happy Sunday or Monday, depending on what your time zone is. Hope it doesn't need storage. Thankfully, it does not. I stocked up and shucked a whole bunch of externals. So I've got 5, yeah. I have 5 10 terabyte spinning Rust drives in there. Really, I just need to go through and like do some software updates on it. So Vaquero, what we're working on is an AI hacking bot designed to go play capture the flag games. So stuff like Try Hack Me or Hack the Box, if you've ever seen those. And it's going pretty well, actually. We're working on an exploitation agent right now. So this is what it looks like. It comes in, this is after it has done recon and enumeration. It thinks it knows a path to go get code execution on the box, and then it passes it through here. So the exploit agent looks at all the data for our target, and it says, okay, I think this is how I want you to exploit it. The planner comes through and builds out a plan, and then this loop right here executes it and does error correction. So after that point, once it's done, it actually needs to pass it back up to the exploitation agent. I haven't built in any of the functionality that once it gets a successful exploit, how the exploit agent is supposed to handle it. So this is the node that we're currently working on right now. And we're just adding the logic to go through and look and see, did the exploit task finish correctly? Is it good? Did we get code execution? And can we hand this back off to the supervisor? So that's what we're working on currently. And it did work. It actually worked really well. It got the bypass on the PHP web shell, which was our test case. And that's what we're doing. We're just coding it up a little bit. Because now that we've got the initial access exploit, we need to go clean everything up. Yeah, it's a lot of fun. That's usually what I do in my day job. I work as a offensive security specialist, so doing penetration testing and red teaming. And I don't actually do coding at all. Very much. Well, I do a little bit, but for the most part, I do it for fun. So what we're doing here is we're just basically, I think of it like we're trying to teach an AI agentic system how to think like a junior penetration tester. It's not going to be very intelligent, but actually it did a pretty decent job. If the NAS ever feels slow, just kick it while it's spinning. Works every time. It does. Does work every time. And hey, Vaquero, thanks for coming online. Welcome in, everyone. I'm actually really excited about this because I can't show it right now because if I navigate away from this page, I lose some tracking data that I'm working on. But there were 2 other primary agents we were working on before this, the recon and then the enumeration agent. So this is number 3. This is the exploitation agent. And been working on this since February because I only work on it on the weekends. It's our fun little project. It gives me something fun to do. People come in and ask questions. We have a good time. And for some reason, people track how many times I'm pooping. You guys are weird. Anyway, After we do that, though, we can move on to the fourth primary agent, which is going to be for post-exploitation. So this whole agent's job is to get what we call an initial access exploit. Just something we can run to get a single command or more to run on the target as a low-privileged user. Once we get that, we're going to then build out a post-exploitation agent. His job is going to be to upgrade the entire connection to a command and control framework. And we're going to do that with Mythic. So that one's going to take a while because I got to figure out how to integrate it to Mythic. AI is just a toddler with a power tool, really fast at being really dumb. That's what I say, Spark. I was like, you're dealing with the hyper-intelligent 4-year-old. And so part of the problem was initially I had really cool structures set up in here. Let me bring up the diagram again. So the task is the basic unit that the agents work off of in here. But the task is very rigid. And so it's not flexible enough to allow exploitation for testing things and breaking things and failing and trying again. So we actually nest under this exploit task. And under that, we have exploit steps. So now we're done with the exploit steps in the task. We got to get this data filtered back up to the task here so the primary agent realizes that it's done. So that's what we're working on. Achievement unlocked. Pen tester holding a pen. Now I'm going to play with my sports tape. Just for that, Braithorn.
Incoming transmission from Marano Gumby. Blaise doesn't have to work tomorrow. Start a hype train for a 12-hour stream.
Oh, good God. Sock would kill me. Y'all want to hear Sock yell at me? Because that's how you get Sock to yell at me. Sock is my wife, by the way, for everybody who just came in on the raid. The supportive, organized caregiver. So I'm constantly trying to evade the Sock, but she knows all my TTPs.
Incoming transmission from Marano Gumby. You have to do it.
I was about to say something from a movie, but I don't know. I don't think everybody would take that correct. About what I have to do. Yeah, she knows every one of my titty pinches, my TTPs. Yes, she does. I totally lost where I was. Okay.
Incoming transmission from Marano Gumby. Just say it.
Just say it. All thing I was going to say was, only thing I have to do is stay black and die. If you've never seen the old movie Stand By Me with Morgan Freeman, when did that movie come out? Dang, that's an old movie. Stand By Me with Morgan Freeman. That's a really good movie. Oh, Lean On Me. That was the name of it. Yeah, Lean On Me. I thought it was Stand By Me. But no, when did this come out? 1989. Dang. I was 5 years old. Really good movie. Classic. I highly recommend going and watching it if you've never seen it before. It deserves better than a 7.4. It's easily a 9.0. It's a really great movie. Oh, Stand By Me was the one with Wesley Crusher. Yeah, that one wasn't as good. Lean On Me is a better one. But you also had Jerry O'Connell in Stand By Me. So it was cool to see space and hyperdimensional jumping dudes hanging out. All right, Vaquero, have a great night, man. Thanks for stopping in. That's the nerdiest and most insane way to refer to your spouse. Yeah, she doesn't like it. It annoys her mildly. I'm not going to say she doesn't like it, but really, in actuality, I'm the one person in the world, aside from her sisters, who are authorized to annoy her to that level. So I don't abuse the privilege, but I do certainly invoke it. Waffles or pancakes? Dude, I usually want to say pancakes, but also there is something about waffles. I would say, actually, yeah, I'm going to say pancakes because I used to be a big fan of like peanut butter in waffles because you had all your little pockets for the peanut butter. But really, I'm more of like a butter man now. I love butter. So like some buttery pancakes, delish. All right, what else did I need to track here? I think that was it. So we tracked that state. We got the target IP. Yeah, so we copied this stuff out. We need to emit the host table back to the state table. What else do we need to do? We need to set the task here. So we check the current task here. Yeah, so then what we're going to do is, if this is the case, then we're also going to check the current working task. We're going to set the status to validated. Boom, just like that. And then we're going to do a return statement right here. So what we'll do is we just return the keys that we need to update. So we need to return the host from here, and we're going to, hold on, I screwed this up. So we need to return the host key back over to here. So host needs to be updated, and we're going to send our local copy of the state table. So every time you see these nodes in here, these are actually Python functions. They're just an individual function that's executing in here. And they take in a copy of a book of truth called your state table, and then we return from those functions updates to that state table. So what we're doing right now is we're going to return the host value here. And then we're also going to return, what else do we need to return? We need to return tasks. So we'll return our task key up to this, and we just return our local copy of the task, like so. Tasks, like that. And actually, I want to put some tracking in here. So after this is done, I don't know why you say validated doesn't work. Validated does work. You're an idiot. Incorrect type check. Disable inspection. No. Suppress for statement. There we go. I'm going to do it again. I'll do it again. There we go. Got it. L-Take, you just denied the peanut butter filled pockets. I'm not much of a peanut butter guy anymore. Otherwise, I would say, yeah, totally. But yeah, that was my jam as a kid. It was, we're gonna do this. Why are you doing this to me? Oh, there we go. That's actually what I needed, I think. This right here. Because you're... There we go. So I don't have any unnecessarily yellow lines in here. Hey, Namer, what's up? Welcome in. Happy Sunday. Or Monday, depending on your time zone. All right. So we got the target IP, we got the initial access exploit, we're storing that in the host field, we're storing that in the task field. Do we have anything else we need to do in here? Actually, yeah, I do want to do one more thing in here. I want to return a messages key to this. So in messages, which is just kind of a tracking value in here. How do I want to return this? I think what I have to do is just do, we're going to make an AI message here. And we're going to say, we're going to format string this. And this is going to come from our exploit agent. So this message actually isn't like your typical AI message. We're not using the messages key for any context management. It's literally just there for more or less logging traffic that happens in the execution. Everything else kind of happens in the state table. National Lampoon's Christmas Vacation is another really good movie. Back whenever they just didn't care about upsetting people. What do you mean you don't care anymore? It's a core childhood memory before going to school on a weekend. Dude, so actually, there's a lot of foods that I don't enjoy anymore as an adult, and I don't think it's because my tastes have changed very much. I think it's because the food's gotten crappier. Until recently. So I saw some kind of viral video going around. Also, Typical. Thanks for coming online. Until recently, I saw a video going around about a restaurant chain called Taco Casa. And I didn't know this. And apparently what happened is when Pepsi bought Taco Bell, there was a franchisor who was good friends with the guy who created Taco Bell. He said, I don't want to be a part of Pepsi. I'm just going to rebrand all the stores and call them Taco Casa. He kept the recipes the same from like the 70s or 80s or whenever this happened. He kept all the recipes the same. And I was like, no. I got so excited about this. I actually paid for DoorDash, which I hate doing, and DoorDashed Taco Casa to my house. And I'm sitting there eating it, and I'm like, oh God, it tastes like childhood. Oh, the burrito. It was great. It wasn't fantastic food, but it tasted like childhood. It tasted like childhood Taco Bell. So for any of you young bucks out there, and you want to know what did food used to taste like when it was good, go to Taco Casa. Fast food is so bad now. You don't know how bad it is. That's what we used to have. We lived like kings. We had 24-hour Walmarts. What do I want to say here? Hold on. Oh, actually, yeah, there's one other thing we needed to do in here. I just realized. In the tasking, we actually need to go validate this task. Let me think about this. Where do I need to inject this into here? Okay, Gubby, just keep an eye on it. I'm 26 and I still eat cereals like I used to back when I was 7. Dude, I tried, man. I got a bowl of, I think it was Cinnamon Toast Crunch, and I tried to eat it. I was like, I was excited about it, man. I was excited. I went to go take a bite of it. I was like, oh yeah, this is gonna taste great. And I'm like, this does not taste like childhood. This does not spark joy. This tastes like cardboard and shame. OpenAI said it's planning on establishing a cybersecurity advisor group called Frontier Risk Council. Good for them. Maybe one day they'll turn a profit. It's investing in strengthening models for defensive cybersecurity tasks and creating tools that enable defenders to more easily perform workflows such as auditing code and patching vulnerabilities. I think Google's actually probably going to beat them to that, especially with some of the stuff they've been doing with Deep Sleep. And all the fallout that caused with the guys over at, what was that? VLC? No, it wasn't VLC. It was FFmpeg. Yeah. Yep. I think, what was the last figure I heard? I forget what the burn rate is for OpenAI, but I don't see how OpenAI is ever going to make money without a government bailout. I'm just going to say it. So, hope you enjoyed those tax dollars while they lasted. What was going on with Oracle? I forgot about that, Ty. I saw something about Oracle was going down, but I don't remember what it was. Oh, okay, we did do that. We validated the current task. Boop. So that one got validated. Blue Owl supposedly dumped a $10 billion deal. Wow. Let me see. Is there anything else I need to do in here? Let me run through this again. So we check to make sure if we're in an exploit task and the status was working, then what we do is we go get our
if we're in a task that is assigned to exploit, so there's a very careful nomenclature here. There's a task that's assigned to the exploit agent and it is working. Then we go get the exploit task from the output field. Then we iterate over those. If it's of the proper type and its status was validated, then we come through and we say, okay, now I'm going to update the state tables, the host target IP, and then we're going to update that task to be validated. All right, I think that's it. Yeah, that should be good. Where's the task in here? Is this even being used? I built this a while ago. One usage, where? Oh, yeah. This was saying it was supposed to be an initial access exploit. All right, that's fine. We can. Oh, I did want to do that. Damn it, I forgot about that. The initial access exploit was supposed to be a dictionary so we can handle multiple copies of it. And the reason for this is because let's say we find multiple exploits on a system. We want to be able to look at those initial access exploits and say, oh, okay, maybe they're running as a low privileged user, or we have initial access exploits that run as admin or root. Those would be better ones to run as here. Damn, I forgot about that. Gumby's good at those puns. Let me think about this. Crap, I forgot about that. So, let me back this thing up a bit. So in this case, the initial access exploit is just a string on the exploit task. But up here, ooh, how do I want to do this? Well, we could actually handle this in one other way, and that is, not that I really want to do this. We could go set up another language model call and have it auto-classify this. Oh. Or, there's one other way we could do this. So I forgot that I had created this, and this exists for a good reason. The initial access exploit as a string does kind of work, however, it's suboptimal. And we're trying to make this efficient. That's kind of one of the kickers here. So let me come back down to the exploit revisor real fast. I need to go add some more time to the box real quick. Add another hour. There we go. Make sure it actually added. All right, it did. Cool. So the box is still up. So one thing we could do is we're giving it 2 items here. Hold on, let me check one more thing. I think I actually did this subconsciously, and if I did, this is going to work out really well. So the last 2 steps that we inject for our exploit, one of them is create the initial access exploit for the target, and one is verify it. So we test the web shell. I think that'll be all right. So what fields did we need in this? We needed if it was a tool or if it was code, and what user we're going to be running it and what permissions we're going to be running as. I think it could kind of successfully infer all that. So here's what I'm thinking we'll do. So down here in the revisor, we give this language model 2 data structures that it can return back to us. Where was that? Here we go. Exploit task updates. So So this should not be a string. This should be a type initial access exploit right here. So we can leave that, and now if we change this, then the exploit task update, that's going to be in our output formatters here. Oh, that means I got to go change a bunch of stuff in here. Actually, I don't think so. It's not going to break anything like this. But now that exploit task updates has this one, we will have to go back and kind of rerun it and see how it runs. I think hopefully that's all the change we need to have. And then it should fill in all of these fields that we need up here. Whether it was a tool or if it was code. And then what user and what permissions we've got. Okay, I think that will work. Let's go back up here again. No wonder why the initial access exploit was throwing such a fit. Where's our host in here? No, go away. So there we define a port, exploit, initial access exploit host. Yep. Oh, yeah. I forgot how that's how we did that. I think we can change this though. In here. This initial access exploit, I think we can just make this instead of a dictionary, we can just make it an initial access exploit like that. We'll see how I break it. See what happens with it. I don't know why I'm laughing so hard at that my eyes are watering. About what? That I screwed up the code again? I mean, that should be standard operating procedure at this point. This one I think I do want to leave. This one... I think I can take out. No, I'm just going to leave it in there. Screw you. Oh, wait, I know why. Because this should come back as an initial access exploit. That's why it's erroring out on the typing. All right, the IDE actually was not being stupid this time. This should be a string. This one, if I remember correctly, actually was kind of being dumb. Oh, wait. No, I'm an idiot. That's because that should be EX task. No wonder why it was throwing a type error. No, that should be perfectly fine. Stop saying that. Expected initial access exploit. Got... Or any of this other crap instead. Alright, fine. There you go. You're going back in there. How about this one? How about this one fine? Yeah, it's fine. It's fine. Okay, I'm going to ignore those other two, but this one I'm going to leave in here. So now, we'll have to rerun the final validator. So when it returns, it's going to give us the initial access exploit, all structured correctly. Oh, are you talking about the big deal pun? Or are you talking about Ellison? Because I thought that was pretty funny too. It's a big deal. All right, did I get this correct now? I've screwed something up, but let's see if it's actually complaining. The code actually hot patched in just fine. Oh, let's go try it. See what happens. So we got to time travel a bit. We got to go back to before the revisor node. So here's the revisor right here. Let's go up. We're going to fork and run from the update node. So it's going to basically take all this state information, jam it back into this node, and let it continue the workflow. All right, cancel. So it didn't flow correctly from there, but that's all right. Let's see what happened to it. So the revisor, once it looked at this, and now we've got this updated task updates. Let's see what it came back with here. Okay, it came back with initial access update from code. Boom, just like that. Language Python. Wait, did we tell it to have a language? We did, actually. I forgot about this. I forgot how much we nested this down. Ugh. Root beer, thanks for going online, man. And my favorite flavor of cola. I don't know. It's a very close second to maybe Dr. Pepper. Stream's running hella late. Don't get in trouble. It's only midnight. It's only midnight. We're good. We good. For now. I forgot I had even set that up in here. So tool at left is null, which is fine. Permissions user trip dubs data. Okay, cool, because it was able to go through and infer all that information from the context we gave it, because we give it quite a bit of information. It gets access to the entire, basically, record of exploitation that we did in here. We just try to limit the data it's emitting to the useful bits. That's cool, though, that it came back with that. Nice. Nice. Okay, so then what did it do once it got back to the exploitation agent? It probably did not go down the correct branch here. So now it's like, hey, we're going to use the existing web shell again. That's not what we wanted. That is not what we wanted. What was the last message we had in here? Sending task 4. Okay, so we need to redo a little bit of this in here. Let's see. So we should have gone down this branch right here, and it should have returned this kind of partial thing right here. So where's the state current task pointing to? And we're going to check the agent on that. So let's go look at the state table. This is all our input stuff. So if we minimize this, let's come down and look at this task real quick. So task 5, it is an exploit agent. It is working. So it should skip over this first kind of check here, not be an issue. And then it would come down into here. Let's see. So after we set this, all right, Braithorn, have a good night, brother. I will catch up with you later, sir. What the heck is this song? I've got a whole list of songs I need to go cut out of the playlist. And I don't know where my pin is because Braithorn made a joke and I threw it. What is this one called? Rip PC? Yeah, we're going to rip this one out of the playlist. It's a little bit too crazy. Oop. There we go. I want some nice, happy, chill background music. Not the kind that's going to make me want to commit war crimes. All right, so we double check this part right here. So if it's working, we're going to grab a copy of the output from this, and then we're going to iterate over that. That should be in the output field. Let me double check. Task, where's task? Yeah, so we index the task array against whatever the current task is. So what did current task point to? Current task pointed to number 5. Boom, that's right where we're at. So in here, number 5 status should be working. So this, we should be operating in this branch right here. So it should have come through here and said, okay, we're going to look at the exploit task. So if the type is an exploit task and the status is validated, that's what we're going to check. Then we extract the target IP, we get the initial access exploit. We then store the initial access exploit in the host table from that target IP. So we've got it tracked in the target now. Oh, actually, I don't think I want to add that. Hold on one second. This actually should be a list of initial access exploits right here. Do I need to actually tell it that it's a list? There we go. All right, so then what we're going to do is we're going to append that. So we'll append that over to the list, just like so. There we go. All right, so we're gonna have a list of initial access exploits that we can go iterate over and check all the properties for it. So that should be good. We set the task itself to be validated, and then we return this information here. Let's say with initial access exploit 4, and we'll just do target IP. That. So the question is, how come it didn't go down this branch here? Does your development have anything to do with N8N? It does not. I like N8N. I think it's fun and it's neat, and you can do some really cool stuff with it. I personally don't have a lot of use cases where N8N is super helpful. So the closest we get to looking N8N like is just in rendering this workflow graph here. But everything done in here, it's not low code, no code, it's code. It's a lot of code. Let me think about this. It should have executed down this branch right here. Yeah. And so so basically what it's going to do is it's going to check to see, let me put a note in here. Check if we had a validated exploit task. That's what we're checking in here. So then we loop over this. Does that have anything to do with 9-inch nails? Not particularly, even though I do like 9-inch nails. Haven't listened to them in forever, man. Dude, funny enough, the main thing I've been listening to recently is the soundtrack to K-pop Demon Hunters because my kids are obsessed with it. And now they're asking for like the epic versions of the songs. They're like, we're driving home from the family dinner we had tonight, and they're like, it's like, Daddy, can we listen to, what was the song called? How It's Done. I was like, yeah, sure, buddy. For like the umpteenth thousandth time. And he's like, oh no, look for How It's Done epic version. I was like, I don't think there's an epic version of it, buddy, but all right, we'll look for it. Sure enough, there's a lot in there. A lot of them sucked. Some of them were good. Let's see. I don't know why it didn't execute down this branch. It should have worked just fine. I don't see any reason why it didn't come down here. Let me see if I can back it up a bit. Let's try it one more time. I want it to run through the reviser, so we have it good. So rerun from here. It could be also that the state table is... It gets a little bit weird sometimes when you do the time travel, like we just did where we fork and run. So it might just be we need to just do a clean run from the start. Actually, we need to go double check the router, come to think of it. Yeah. Because what we need to do is, let's come back up here. Let's check this run again. So what did the exploit... Obviously, the exploit... the router returned exploit step planner. So let's go double check that node real fast. I'm going to minimize this. So the pre-flight check should definitely be false. Let's see. So current task would be task 5. Pre-flight check is true, so it's already been done. So if not pre-flight check, go to exploit planner. If the last message is a tool call to exploit suggestions, then it's going to go to handoff. The last message shouldn't have had tool calls in it, though. Oh, you know why? What did this node actually return? Because it shouldn't have returned anything. So look, what we're doing is we're looking at the last of the messages as it exits this node here. So why did it make a language model call? If we put in a return statement, it obviously cannot be hitting the return statement properly. Something is funky in here. Maybe it's this. So we go to state, current task, output. So this current task here is number 5. So then if we come down to task 5, here's task 5. We get that list right here. And so from output right here, this is it. So it's an array. So we grab... Is this the output one? Yeah, I think we're gonna have to just run it from scratch. Let's do that. I think that's the problem. I think the thread is kind of corrupted in memory. So let's just rerun it from scratch here. Let's do that. Another good book is My Worst Journey by Helen Back. Golly, dude. Bruh. All right, so what we're doing is we're going to let it do a complete new run of the agent. We're going to do a clean thread here because I think when we forked it, it got kind of funky. That was a pretty good one there. I got to show y'all something, actually. So over in... I posted this up on Discord. But this started an entire firestorm at work when someone posted this.
Yep. Family has to stick together. And it actually kicked off an entire pun battle about Full Metal Alchemist whenever that got posted in the work chat. Good travel book is Holiday Spots by Sandy Beaches. Dude, no, just that hurt. That hurt to read. All right, looks like it did the successful bypass, maybe? Let's see. All right, so the special agent right now should be attempting to upload the web shell. All right, so the new bypass for the web shell uploaded correctly. So now it should start doing create the initial access exploit and then test it. Wait, why are we going back to the special agent node? What is going on here? I'll just let it run for a second. Then we'll dissect the trace and we'll see what it did. Hyper intelligent 4-year-old with power tools. That's what a language model is. Oh, I know what it did. It tried to do a .jpeg extension. So, okay, so what happened now? Did it try to bail out? Key error updates. All right, well, let's go see what happened. So this is good though, because it tried something stupid. Let's see what it did. So our steps, when it generated the steps, came through and said, standard steps for what we expect for this. Get the artifact, upload it to the panel, navigate, things like that. So we get the artifact, navigate to the panel. It then tries to do the upload. So what happens post-upload? Revisor should say, it didn't work, and here's our suggested approach to fix this. The server is filtering PHP files. Common bypass techniques include renaming with double extensions, using alternative PHP extensions, things like this. So what does it decide to do? Insert a new step before the current step and rename with the file bypass technique. All right. So reasoning for PHP JPEG. Because I'm dumb. That's why. Dumb. All right. So it tries that. So it tries the double extension. That doesn't work. And then let's go down a bit more. So then it does the upload. What does the revisor say after this happens? What does it do? Because the revisor really is all the error correction that's going to happen here. So it marked the current step as validated, upload completed successfully. Marks the next one, which is RUO1J. Which is send it to access it in, or navigate to the uploads directory. So it calls this one again. And what it should come back with is it should show the PHP code in here. Oh, it actually saw the previous one from the other web shell, PHTML. We should probably go SSH in and delete that.
Hey, Bishdev, thanks for coming online. Welcome in, and I hope you're having a happy Monday now. Unless it's still Sunday if you're Pacific time, but welcome in. Let's see what it did here. So what was the reasoning that it gave us now? All right, so step completed successfully.
Incoming transmission from Marano Gumby. Check the time on the box.
I've been using the timer, so we should still be good. We should still have an hour on the box. I haven't remembered to actually use the timer this time. So it saw it up in uploads, and then it tries to call PHP web shell dice code here. So that fails, but then the reviser comes back and says, I don't know what to do, probably. Okay, so the response shows the PHP source code from the dice code web shell itself, not the command execution output. The response contains the actual PHP code for the web shell, so key observations. Web shell's not executing the PHP code. RCE status not obtained. Reaction. Current step has failed because the upload file is accessible but not executing as PHP. We need a different approach to achieve code execution. So revision strategy. Since PHP JPEG allows uploads but doesn't execute, we should access the file with a different approach or try an alternative file present. So then it calls step updates, but it just doesn't put anything back in here. That's pretty bad. Let me look at the input for this real quick. So this is good to see though when it does fail like this. Let's see. That current step just needs to go away. It's not important anymore. All the iterations were set to 0 though. We could take an ultimate option where if it doesn't return any updates, we bail out and we send it back to the exploitation agent. "50 Years in the Saddle" by Major Aspern. Damn it, Gumby. This would be a prime opportunity if I had built in the options for it to bubble back up to the user to ask for something, but I haven't built that part out yet. You did get me. I'm out of water, unfortunately, so my throat's getting parched. So what happened here is it did call it, but it didn't have any updates to put in. Let me go look at something real quick here. So we'll leave this part for just a second. Let's go take a look at down here in the reviser. Actually, we need to look at the reviser, and then we need to look at the, what is that function? The step router here. So we can correct for this, I think, fairly easily. We can give it one more option for what to return. What do I want to call this? We'll call it exploit bailout. And we'll make this another model in here. So another Pydantic model. And we're going to have one field in here. So if we get an exploit bailout, we'll do a reason, and we'll just make that a string. And we'll define that as a pydantic field. And we'll give it a description. Reason for abandoning the exploit task. Yeah, I know I misspelled that. I don't spell well. Did I really? Okay, I did spell it correctly. So then what we need to do is that, unfortunately, when we add that to it, that means we got to go add it down into the tool list here. So let's see. Exploit bailout. There we go. And then we need to tell it on the prompt what we're going to do here. So let's come back over to the prompt real quick. Let's see. We'll say if the exploit task, approach fails, what did it say? Actually, this is important what it said here. Revision strategy. So since the PHP JPEG extension allows uploads but doesn't execute, we should try accessing a file with a different approach or try an alternative file that's already present. Yeah, we could try that. So if the exploit task approach appears to hit a dead end, yeah, well, that's what we'll do. We'll say this. We're going to stick with like similar verbiage. Instead, call exploit bailout. There we go. There we go. So what we'll do is we'll give it the ability to bail out on us here. So we save that, and then we need to come through and update this a bit. So if we say exploit status update, that should be fine. And then we'll do one more of these right here. We're going to do one more elif statement. And this is going to be exploit bailout. What did I call that? Yeah. So if we bail out of this here, then what we're going to do is we're going to set our exploit status. We're going to set that to failed. We'll also have to check this in here. I'm working on it. Chill. Well, I'm gonna have to populate this, aren't I? I'm working on it. Chill out. We'll say state current task. There we go. So current task, and then this is going to be Get current exploit task from the state table. I can't line return this? Oh, it doesn't like that. Let's take this out. Let's we'll bust this out into another. Actually, we already have that in there, come to think of it. Status equals this, and then we'll check the status of that. There we go. So if we don't have a current working exploit task, or if the status from that exploit task was failed, make this very clear what we're working with here. No, actually, I don't know if that's what I want to do. Actually, this should kick it back because then we shouldn't have any. Come to think of it, if we fail that one out, which we've already done up there, we should be good then. Actually, this should cover that entire situation right there. All right, cool. So we got that. We're gonna say it's failed. I'm gonna put one more AI message in here though. So we're gonna say AI messages end.
Incoming transmission from Mariano Gumby misunderstood, artistic.
Oh. Damn it, Gumby. Let's see what we can do with this. All right, so if we bail out of this, I'm gonna leave. I do want to have a message in here saying what we're doing. Let's put a note in here saying we're bailing out on exploit task, and then we'll have it do the current exploit task. Make that a format string.
Incoming transmission from Mariano Gumby. Sorry, not sorry.
I know you're not sorry. There we go. All right, so we'll log a message so that we can check it in the messages queue, and then we're going to mark that as failed. If that is failed, there shouldn't be anything working, and then we should route back up to the exploit agent to take another crack at it. See if we can rewind this a bit here. So rerun from here. We'll see what happens. Actually, it's going to try and do a step updates again. Did it do the exact same thing though? So why is it bailing out on this? I know we're not hitting anything close to the context window because overall this is only 7,000 tokens right here. Let me double check something in the prompt real quick. So for the system prompt that we sent it, did it have the new data in here? Instead, return exploit bailout. Okay, so we gave it the bailout option, but it chose not to take it. Why? Because hyper intelligent 4-year-old, that's why. Oh no, I get why it's doing it, but also it's doing something fundamentally wrong here, which is it's not populating the exploit steps. So we're just going to tell it, you must always populate this. Let's look at what happens if it fails. So here's the instructions for if it completed successfully. If it did not complete successfully, use the following criteria to update the steps in the array. So what we're going to do is we're going to do something silly here. Never return an empty. What did I call this function? What did I call this thing? Exploit steps. Exploit step updates. It must always contain the complete data set when called. It might sound dumb, but maybe it'll work. All right, looks like it reloaded just fine. Let's try it again. Maybe third time around was the charm. So we can double check that that actually populated incorrectly by just double checking in the system prompt. In fact, we know it updated correctly because when we saw the tool call, it had 3 tool calls instead of just 2. All right, so it failed out again. What are you doing, step processor? So it called step updates, but again, it just comes back blank. The issue when it was coming back blank before was, I think it was because we were referencing the wrong data structure, and we have the correct data structure being referenced now. Pentagon just released a press release about kernel of truth and lot of lies. I have a feeling you're just querying ChatGPT for these at this point. I'm going to tell, if you're returning a blank exploit step updates, you must explain why. Yeah, why it is blank. Let me actually make sure that actually got populated into this. Let's go double check the system prompt real quick. Maybe it just didn't populate properly. Let's see. Here's our instructions. Yeah, no, it had it in there. Never return it. It must always contain a complete data set when called. All right, let's go try it again. We'll let it load up, and then we're going to run this one more time. Rerun. Did that language model, actually, did it show all the data in here? Yeah, it did. So it showed all of the data for the step in there and the exploit task. Okay. So it did the same thing again here. You know what? I had a script in here somewhere. Let me look at something real quick. I had it somewhere in here. Was it in tester? Hold on. Let me double check something real quick. Oh, it did actually. Ha! I forgot about that. So actually, I put a little bit of a backdoor system over in here. Forgot about that. Actually, we can call this webshell.phtml. I wonder if that phtml is throwing it off. So we're going to wipe the system without having to like redo the entire thing. Actually, hold on. Yeah, I think we already had that. Did I already grab that? Hold on, I'm gonna laugh if I did. Hold on one second. So I think I actually grabbed the root key off that box, and I just forgot about it. I did. Hold on, let me get in the proper IP address here. I think I did. Unless they rotated that key there. Hang on a second. I forgot that I had dumped that. Root's password. I don't know root's password. Oh well. Oh, wait, I forgot I had put this stuff over in tester here. This was for running a single command. This was for... Oh, adding our SSH key. That's what this was. Yeah, that's funny. What was... Hold on. I forgot. I think I built myself a backdoor and forgot about it. I completely forgot I had put that in. Now that's funny though. Let me see if this actually works. Just grab this real quick. Yeah, so what I had done is actually built myself I forgot about this. So once we've got that web shell up there, right? So we had web shell.phtml, just like that. What this does is it actually goes through and adds it over to oh, actually, this just catted it out. That's what it did. Which that would actually still work. We don't even need the SSH key in that case. Because that gets us our authorized keys out of here. We'll have root permissions. Actually, hang on. I think this was how I did it. Yeah, I'm pretty sure that's what I did. Yeah. Pretty sure that's what I did there. Yeah, there we go. So now I'm root on the box. I forgot I left that on there. Oh, that's funny. All right, hang on. I'm going to fix this up a bit here. That's too damn funny. All right. There we go. I forgot I put this in so that once I get the web shell on there, I can just instantly root the box. And I can put it in the background. I can just instantly get it. Oh, too funny. All right. So now that I'm in here, I'm going to go clean up the box a little bit. So we're going to go var tripdubs HTML uploads. I said I need a CD to that.
Incoming transmission from Marano Gumby. Oh yay, FYI you have a backdoor to root lol.
Yeah, thanks for reminding me, Gumby. Yeah, Ty, which router logic are you talking about? And yeah, I'll run you through it. That's funny. All right, I'm going to try running the agent again now with the new information, and let's see what happens. I'm going to run it from scratch. So let's make a new thread up here, and let's run it.
Incoming transmission from Marano Gumby. In all honesty, I forgot about that too.
I totally forgot about it. Oh, so the step router, what it's doing here is after the planner injects it down into this loop, basically the step processor should look at the exploit step and then decide what it's going to do. It can either call a tool or it can call a special agent. So the router here puts that into this flow here. They both flow down to the updater, which makes sure that the information gets updated and tracked in the state table. Then it goes to the reviser. Reviser then says, okay, here's the updates we need to make to everything we're tracking. And then it goes to the step router in here. And so the step router basically says, if this code meets a condition where like we have more things to do, we're going to send it back to the step processor. If it doesn't, or like we bail out or we don't have anything that's working, we're going to go back up to the agent. The main way you get it to choose the correct tool is by massaging the wording on it, because all these are working on is word vectors when you think about it. So from those word vectors, you've got it set up in a way where you try to keep the wording as close or similar as possible. So if you use a lot of disparate naming conventions in things, it makes it a lot more difficult to it. So I try to make sure the naming is very clear. And there's a lot of work on making sure the verbiage is very clear on it. So why did the reviser come back saying, I don't know what to do here? Someone in the chat was asking earlier about this, like, hey, have you come across any problems with it refusing to do certain requests? I wonder if we finally hit that. So up here, because it's not giving us any reasoning about why it's doing this. You see that? There's a cool book on the history of Exxon by Phil Urup. I don't know if we need to clear the memory or not on this. I do need to go extend the time again. I don't think it's a memory issue. It looks like everything is operating correctly. I wonder if it's the language model actually... Not the language model itself, because you got to remember, this is flowing through certain layers over on the Anthropic side, right? So what we're doing is we're making API calls over to Claude, right? So we're using Claude's API. So any kind of API middleware happening here, when it gets down to the LLM and then comes back, right? They could have some kind of intercepting middleware here that's saying, nope, we're just not going to process this. It's kind of wild. The only Docker container that's still currently running is... What's the one that's running? I mean, we have a whole slew of like abandoned browser containers. We've got Mythic up and running right now. The only one that's actually running is Dreadnought, but Dreadnought's been working just fine. This isn't an issue with Dreadnought. Not Dreadnought, with RoboPages. Let me kill all those, get them cleared up. So here's what I'm noticing. Let's look at something real quick. The reviser has no trouble until it gets to this issue where it realizes there's a problem, right? Actually, to what? There was one other thing we did here. I'm going to try something real fast. I'm going to delete this out. And I'm just going to leave it like this. Even though we had the exact same issue come back from this. I tell you what, let's go ahead and let's do this. I'm going to shut the whole server down. I'm going to restart it. So we're gonna do a full hard reset here. And let's try this again. No, because this is not an issue with the virtual machine. We could this all is being traced on that side. We'd see the issue appear in a different spot. This is literally an issue happening with the data that's coming back from Claude. Did I get any nasty grams from them? Like, hey, we're watching you? I don't think I did. Yeah. No, nothing like at least in an email saying, we're watching you.
Caution. A virus has been detected.
Your cyber doctor virus detected in the network.
The Cyber Doctor. What's up, guys? Welcome in, Raiders. Melty. What's up? Let's see. Are you using a Claude agent thing? Not exactly. We've built our own agent over in LangGraph to play CTFs for us. And now something weird has recently started happening where it's not returning data back from the language model. It's giving us all the information back. We had given it an additional tool. I don't know what's happening with it, but we've wiped it out. We've restarted everything, and we're going to try it back from scratch. Hey, Mulgars. Welcome in. Happy Monday. It is definitely Monday now for most of the world. Except maybe like Hawaii. But they don't count. Let's see. Let's see what it's doing here. If it happens again, then I'm going to say it might be an issue on the Claude side. And I don't think it's an actual like issue because it was working earlier. But the problem seems to come in whenever it notices that the exploit attempt failed and it's trying to work around it and make revisions. Actually, no. Now it says remote code execution achieved. So I wonder what's going on here. We'll just let it run for a second. We'll let it cook. Yeah. Still Sunday in Oregon. Oregon doesn't count. Neither does California or Washington. Which is funny because my company's based in Washington. So it got the code. Why is it? What's so different now? Hold on, I'm getting ready to cancel this because the exploit agent is probably going to route back to the planner. So we still have to figure out why the exploit agent is failing on us. But this looked like it works just fine. There was no difference to it. I don't get it. It went all the way through the exploit chain. It got code execution from the web shell. How much did this run cost? Let me see. Every time I have to run that, it costs between 50 and 70 cents. I mean, it's not terribly expensive, but... Yeah, it even returned the initial access exploit. It's so odd. I do a lot of vibe coding, no football coding experience. Started off bouncing between different web clients. DeepSeek to GPT to Gemini. And it was hell. Moved to VS Code and Claude. Dude, actually, I like Claude Code. I'm not using it for coding very much. I'll use it for troubleshooting a little bit. Like I had an issue here. I had a power outage at my house. It shut down my dev server. When I brought it back up, it did something where the packages weren't aligning properly. I used Claude Code to help troubleshoot that, but for the most part, I'm doing a lot of the code, all the coding by hand. Been on anti-gravity using Claude models. Man, one day I hope to make, millions of dollars off of forking VS Code and modifying it. Gemini 3 Flash is atrocious and everyone's saying it's good is full of it. There was one of the guys in the chat actually really likes Gemini 3 Flash, so. Now, one of the things that's funny is the language models do tend to have a kind of personality to them, and it might just be that that doesn't mesh with what you're working on. Hang on one sec, guys. I need to get some more water. I'm dying of thirst. I'll be right back. All right, I'm back. I'm back. Guess who's back? Back again. All right. I really don't get what the difference was. Why this call chain just went straight through. I had a lot of good progress working on workflows. Main issue I'm having though is I don't have Max to use the workflows properly, so it's taking a lot of tokens. Yeah, I don't use Claude Code Max. No, unless I can get my company to pay for that. I'm not shelling out $200 a month for that. I'd get a lot of steaks for $200 a month. I'd rather have the steak. All right, so the exploit agent has to be going down the wrong path here. I tell you what, let me go back out the stuff I put in here about the bailout. Because I do need to have information in the prompt that allows it to fail out of this. I gotta remember, what did I do for that exploit steps update? Let me see. Or exploit task updates. Initial access, exploit, and status. Okay. Let me update this real fast. Because we do need to give it a bailout function in here. Let's see, we'll say set the initial access exploit field. We can actually just copy these values right here. Copy those. We'll say set that to null. And and set this field not to validated. That is incorrect. Set the status field to failed. There we go. Just like that. So at least we do have a bailout function now, which was an oversight. Let's come back up here and figure out what's going on here. So this should go check the output, get the array. That should be a list of exploit tasks. Hey, Skywiper, thanks for coming online, man. Welcome in. Welcome, welcome, welcome. All right, why is it not going down this list? It's got to be because of this. Annoying debug. Not exactly optimal, but I'm going to try this. So the reason why that whole annoying debug option exists in here is because here's where we get the, and there's just so much stuff that flows through here. I needed some way to make it extra annoying when it comes through here. So that's what it's going to do. I'm going to run this again from the exploit revisor. Here we go. So we'll let this run from here. So we're going to fork and have it run again. It should go up to the exploitation agent. Cancel. All right. Let me go see what came up from that. Oh, it came back as a class of dictionary. That's why. So it's not matching the... That's what's happening. Right here. Because the exploit task is a typed dictionary. That's what's happening. It doesn't actually match against the exploit task type in here. Alright, so... What we'll do is we'll just check this first before we actually even hit this. So what we'll say is there should be a keys then, because it's going to be there. So if keys contains status, that should work, I believe. I gotta remember how to do that. Let's see. Python check keys in dictionary. Yeah, that should be it. Oh, actually, I got this backwards. It should be if status in. I got it backwards. All right. So we'll say if status in. There we go. So if it has a status key, then it's going to check it. Otherwise, it's not going to. Which, if it's a proper exploit task, it should have a status key. Cool. Bad laughing. Bad. Oh, what have I been chewing on? This is Lucy nicotine. So, which I should probably lay off of because I need to go to bed soon, but I really want to see this working. And so it was just figuring out why was this check not happening. So let me hot patch this code in real quick. All right, let's go run this again. Let's try it one more time. 37th time is the charm? Something like that. Oh, the exploit agent decided it was just going to crap out on us. What did it do? Wait, what happened? Ah, here it is. I was like, where's the trace? Oh, we didn't like this. Type error. Argument of type built-in function or method is not iterable. What? Oh, we could actually do the, okay. It's because I called keys instead of the keys. Okay. All right, fine. Because I forgot a pair of parentheses in there. I kind of like this other way, though. If we'd use the .get on here. Yeah, so let's actually do it that way. So we'll get status. What do we say? If it's not none. There we go. We'll do it that way. It looks a little bit cleaner in here. So because the get function can return a none type. So if it's not none and it's validated. All right, another try. Let's do this again. Rerun. Good news is these forks actually aren't costing us anything because we shouldn't be doing very much language model calls. Except it's probably like, we don't like your code. You suck. You're a horrible person. You're terrible. Oh, yeah. Well, good. Actually, that means it's going down the branch, but I forgot the initial access exploit is not a list now. So this was line, what line was this on? Line 81. This one right here. So this is in our host field. So let me go double check that. So we got a host, that's a type, matches a string to a host. We index that on the current IP address, and then we go to the initial access exploit. So that's a host item here. Initial access exploit is... Wait, hold on, that should be a list of initial access exploits. Ooh. That used to be a different structure. That's why. Oh. It's because when we initially ran this, what happened is this was a different data structure. So when we load the saved state table from the pickle on disk, that's what's doing it. I got it. Ugh. Hey, Faust, what's up? Let's see. Can I get an overview of what's going on in the background of hacking? We're building an AI generator or a RAG-based utility. Oh yeah, dude. No, this is our little AI HackBot. Its whole job is to go play CTFs, like Gumby was saying. And what we're dealing with right now is just a little bit of code massaging to get it to take it. So there's a little bit of a dirty hack that happens in here, which is we have this overarching graph. This is actually just a subgraph of the overall workflow. So we've already gone through a recon and an enumeration phase, and now we're in exploitation. So to keep from having to rerun those previous phases, there's a state table that passes through all of these. And if I just ran this agent by itself, it would start with a blank slate, and it wouldn't know what to do or how to do it. So I put in this little cheat code right here. So this is the pickle node. What it does is, whenever this agent gets called, it looks at the state table and says, does it have anything in it? Oh, it does. I'm going to save a copy to disk. Oh, it doesn't have anything in it. Okay, then I'm going to load a copy from disk. So it is my dirty poor man's way of not having to go rerun the initial recon and enumeration and just let it do its thing. But actually, it looks like I do need to run it from scratch again, because one of the data structures changed, and that data structure gets run over in this initial part right here. So this is the overview of the entire structure right here. There's one more missing node over here that we're going to add in for post-exploitation. It's going to be what happens after the exploit agent is done. And we haven't started on that one yet because I've been working on the exploit agent, but so far it's actually working out pretty well. I'm going to run it from scratch here. Unfortunately, I got to go grab the data real fast. Hang on. Where's our test data? Here we go. So it actually gets through the first couple really good. We put some neat optimization in here too. Like, for example, if it wants to know about something on the host, it will check the information that we already have before it tries to go run a new scan or anything. We've had a lot of fun building it. Been working on it since about February, and I just usually work on it on the weekends. Normally, I'd been done streaming like 2.5 hours ago, but I don't have to work on Monday. I've got the week off. So, and Sock, I just checked on her when I went to go get some water, is passed out, which is what I expected. So she's not around to tell me to go to bed. So right now it's going through the recon loop. And recon and enumeration, they're fairly similar. You can see right here. There's recon, there's enumeration. They're pretty much identical in structure. The exploitation agent, though, is a lot more complex. The post-exploitation agent's going to be a lot more complex. I'll probably look at maybe for the post-exploitation, potentially using a LangGraph deep agent. I need to do some reading up on it first, though. I'm not on a CTF team, no. I do penetration testing and red teaming for a living. That's my day job. And I don't actually enjoy doing a lot of CTFs. And I know that sounds weird. It's just I don't. It's like you do it all day and then you're going to do it all night. But however, building something to go play the CTFs, I do find really fun. So that's what we've been doing. List has no attribute keys. Oh my. That's okay. Let's go take a look at that real quick. Where did it throw the error? Let's see. All the way down here. Yeah, I forgot about that. That's line 176 in validator in the exploit agent. Okay, oops, gotta go check that. But that's fine, because that means it actually did go save this in here. I forgot. So what it was doing is doing the pre-flight check before it tried to exploit the target. It does a check to see, do we already have an exploit for this host? Where's the validator? There's the agent. There's the validator right there. So the IAE in this case is we get the target's initial access exploit. The target's initial access exploit should be a list here. So this shouldn't be keys. This should be the length of it. That's what we want. Yeah. Excuse me. Faust, thanks for coming online. Welcome in. I've been in adversary emulation for a few years, and I've wanted to build something similar, not for CTFs, but for automating some of the process in post-exploitation and log cleaning. So I'm not familiar with Mythic myself, but I've been learning Loki and Sliver on the side. Glad to see another engineer on Twitch. This is pretty awesome. Dude, I appreciate it, man. Dude, I love Mythic. Mythic is really, really cool. I don't know what I'm doing here. Hold on. Length of the initial access exploit. There we go. So we're gonna check, just check the length of it in here, then we'll be good. Yeah, I've been doing. I just recently kind of moved into adversary emulation about a year ago, a little over a year ago. Before that, I was doing pretty much straight penetration testing. So overall, I've been doing offensive security for 7 years now, and been in IT for like 15 years, and had just been doing hood rat stuff with computers since like the 2nd grade. That's funny that I forgot because we changed that data structure. We had to go fix it up in here. That should be okay though, because what we can do is we can just, now that we have the new pickle with the correct data structure, we can just rerun this. Yeah, I really like Mythic. If you're doing it for adversary emulation, you're not going to want to use any of the off-the-shelf agents, though. You do have to take the time to go like build your own agents and work on. You could probably get away with using like the dynamic HTTP C2 channel, but once you get used to it, Mythic is really sweet. I enjoy the heck out of it. It has so many creature comforts, especially over something like Cobalt Strike, where the reporting and the logging on it is so annoying. Nobody can afford Cobalt Strike anyways. I have Cobalt Strike at work, and I'm sad every time I have to use it over using something like Mythic. And there are some cases where I do need to use Cobalt Strike because Beacon is actually really well put together. It's a very good agent, especially with all the creature comforts you've got to it. But I really enjoy when I get to use Mythic. Yeah, I'm actually going to try and get Cody onto the stream maybe sometime this week. But if I can work up a mobile streaming setup, I might just try to do that with him on the first week of January, because he and I are going to be at a conference together in Vegas. So Cody's the guy who wrote Mythic C2. So he's a buddy of mine and super, super smart guy. One of the most chill dudes you'll ever meet, too. He's got the patience of a saint. I was going to go with Jeff. But, Mello, thanks for coming online. Welcome in. No, this is in the first week of January. It's another like company get together type event. So he and I are both going to be there. So I might try to see if we can do it then, because I might be able to get some other really big brains on the stream, and we can just have like a sit down and talk about stuff. I got to see what the schedule's like. Dang, that's coming up so fast. I can't believe Christmas is this week. What's it doing here? Let me see. Uh-oh. The reviser was not happy. Did it return blank data again? Are we? I swear we're getting shut down by Anthropic. That's the only thing that kind of makes sense. There's no reason for this. I don't get why it's doing this. Come on. That's kind of what I was thinking to do, Gumby. I just got to talk to them and see who would be up for doing it. What is going on here? Where it just absolutely... I mean, we could take a nuclear option where if this returns and it's blank like this, that we just bail. We bail out on it. I don't like that option. I think it's lazy. Let me try rerunning it again. How much did this run cost? Let me see. 45 cents. Hey, not bad. Not bad. All right. I'm going to try this one more time. Yeah, it looks like it's still returning blank. I do have to wonder from what one of the guys in chat was saying earlier, like if this isn't something that... Well, you know, actually I can cheat just a little bit because we're at the very... That's it. You know what? It worked last time, so let's try this. Let's kill the server and we'll restart the server and we'll see if it fixes it. An iteration thing, possibly. But it doesn't, it's all the reasoning steps though say, I'm gonna do this stuff. Let me provide the exploit steps. And then bam, it just bails out hard. Don't know if this is actually gonna work whenever I rerun this. I don't think it is since I restarted the server. Well, actually, it is. All right, so it didn't like that. It's doing the exact same thing where it just returns blank data. This would be a case where if I had put the human in the loop functionality here, this is where it would bubble back up to the human. Let me try a new blank run here. But it seems to be when it gets to the point where it tries a bypass to the upload restriction that fails, then all of a sudden it like panics out. So I'm not 100% certain if this is Claude or the guys over at Anthropic like filtering the model or not. Because I would have thought that for all the stuff we've got flown through here, like exploit and PHP web shell and yet all those, I would have thought those words might have flagged it already. If that was the case to it. Let's see what happens. So it should be trying to, I think, upload the web shell right now. The initial upload that should fail. Can you try to force it to do the right type and see it goes through? Maybe. So it looks like it did the bypass. Let's see. So now it's going to try and do the upload for the renamed one. I'm just catching it real fast as it blips through right here, and I know my big old fat head's in the way, but let's see what it does. All right, so it says it successfully uploaded the bypass, so cool there. Okay, Faust. Yeah, I'll check it a little bit later. It's pretty easy to find me on LinkedIn. It's not like it's a big secret. Okay, so the revisor failed out again, meaning it probably came back with a blank revision. So it did call step updates. So what step was it on here? Let me back this up. So the early RCE check happened and then it bailed out again. This is bogus. I'll look at something real quick because I had talked about putting Open Router in as the primary on here. That surprises me. I didn't realize that the context window for Opus was only 200K. Whereas it's $1 million for Sonnet. Sonnet is what we're using anyway. Sonnet's also a slightly more than half the price of Opus. Opus is $25 per million output tokens. I'm curious where Open Router's actually hosting these and how they're getting access to it, because do they have Grok in here? Actually, I'm curious. They have a couple of the Grok models in there if you wanted to try those. I'm pretty sure you can get just about any model you want up here. Well, here's the kicker. It looks like it actually did work, though. And PHP 5 would work if we did that. And the one it tried was actually PHTML. It said, who am I? It got TripDub's data. But then once it got down to this point here, let's go take a look at something. Let's look at the state table and see how it looked when this happened. So it's not getting the entire state table. It's just getting a slice of it, which is the list of things that we send out to it. So this list of steps right here. So it renamed it to PHTML, which is fine. So here we did access the uploaded one. So when it did this, for accessing it, what did it do? Oh, it called the PHP web shell Diceco for it. So it didn't even try it. It's just like, hey, we're just going to try calling the web shell with our helper function. So it did that. So it should have then skipped this one and gone to here. But you see how it just dies, essentially. And this is not a lot of tokens in here. We sent it about 5,000 tokens. We got about 1,000 out. So there's no way we're stressing the model a ton. Yeah, that is hella weird. What the heck could be causing that, man? Let's see if, I mean, maybe someone else has run across this issue. Let's see. Let's do Claude 4.5 Sonnet returning empty tool calls. I mean, this was from June. Let's see, this behavior's been reported in the LangChain JS library where tool implements are frequently set to an empty object. Issue occurs more often than not, with valid tool arguments being filled only about 20% of the time, suggesting a potential problem in how the model's output is being parsed or handled by the client library. Now, this is in LangChain JS. This isn't necessarily in LangChain Python. Issue is not exclusive to a specific tool or a use case and appears to be related to how the model's response is processed, particularly in environments that rely on structured parsing for tool calls. So, for instance, a bug in the Lite LLM library was identified where streaming tool calls with no arguments resulted in a JSON parse. Let me try something here, because we actually don't need the streaming output. It's kind of cool to see whenever it happens, but in our configuration, technically there shouldn't be an issue with this. Where's utils? In the configuration, if we change this, if we just turn on streaming to be false here, I'm going to try rerunning it. So if we don't have it trying to do streaming and processing it that way, will that make a difference? Let's go give that a try. Still looks to be streaming. Now all of a sudden it's like, okay, no problem, bro. We could also implement a try loop in here where it retries it if it gets an empty response. Maybe have it try like 3 times before it bails out. But now it's working. It's so freaking weird. It actually did the exploit handoff. Let's go. What that means is now it would have returned this back up to Stinger to say, hey, what do next? Yeah, I don't know, Gumby. Okay, so here, actually, to test the newly generated exploit, so it actually did do the get here. What did Revisor come back with here? Okay, that's suboptimal. Oh, wait, no, this is perfect, though. Hold on. Here's our tool, right? So the tool name was called PHP Web Shell Diceco, and it came back with the args. Okay, this is valid. It can either return code, or if we already have a helper tool call, like in this case, we built helper functions around the Diceco web shell. Permission level user. User, TripDev's data. All right, I want to do one more run on it. We're going to do a run from scratch here. Let's see what happens. And this will probably be the last run. I'm probably going to wrap up the stream here. I really doubt anybody's over on InfoSec streams.
Caution. A virus has been detected.
Zeta Shaw virus detected in the network.
Hey, Zed, what's up, guys? Welcome in, Raiders. You actually picked a really cool time because I think our little hacking bot just made a breakthrough. I think I am about to leave, man. I've been on for 5 hours now. But we're running through this again real quick. But anyway, welcome in, Raiders. By the way, guys, my name is Blaise. I am hella tired because it's almost 2 in the morning here in beautiful Dallas, which is really just a pimple on the backside of Texas, which I love. Dallas, I could live it or take it. But we're working on an AI hacking bot to play capture the flag games. So something like Try Hack Me or Hack the Box, if you're familiar with those. And the exploitation agent, the one that's actually supposed to go get us code running on the target, is seeming to be working after we're doing a little bit of tweaks to it here. We've been stuck troubleshooting this loop for months, figuring it out, massaging it, working out the kinks, getting the knots out of the muscles, and then now it looks like it's actually working. So it has to do a very minor, simple exploitation, but it looks like it's doing it. I will, man. No, don't apologize, dude. It's the way it goes sometimes. What were you up to tonight? Yeah, gotta get those knots out of the muscles, man. Actually, the problem we were having is when this processing loop was running, I built some really pretty, what are they? Data structures to kind of handle the steps that it needed to do for the exploit. But it turned out to be too rigid. So we actually had to back those out and give the agent a little bit more freedom. You give it too much freedom, it craps out on you. You don't give it enough freedom, it craps out on you. That's kind of the thing, Hayes. So, Gaga and that guy, thanks for coming online. Both y'all, appreciate it. Yeah, I don't have to work today, so I got to stay up late and work on this. I was really hoping to get this exploitation agent done before Christmas, and I think I might just barely pull off a Christmas miracle. Because I think we've been working on the exploitation agent since June. It's been by far the most complex of the agents so far. So what we have is we have a supervisor that's really dumb. It's not doing very much. And we have a recon and we have an enumeration agent. So their job is to go out, gather details and information about the CTF target, and then exploitation agent is supposed to hack it. So, and Simman, thanks for coming online. So we're just sitting here, we're watching it run through the workflow right now, where each of these nodes roughly correlates to a single call to a language model. And we're trying to see if we can guide it like a junior penetration tester to playing these CTF games. That is how it all goes in all the tech companies. Eventually, I'll show you here in a second after this run finishes what the supervisor is supposed to do. But right now, it's very dumb and it's just all in code. It does not have any additional intelligence to it. Oh, the revisor. You're killing me. You're killing me, Smalls. I'm sitting here and I'm telling everybody how great you're doing, how awesome you are, and then you crap out on me. So we're running into an issue here. I thought I'd fixed it, where it will be working and then it will just all of a sudden stop sending data back, and that's breaking it. I'm about to take the nuclear approach on this, which is... So what's happening is this should be returning basically a JSON structure back to us. And in this case, it's returning blank. So this is where it updates all the exploit steps as it's running through here. And occasionally it just decides, I'm just going to panic out, have a complete crash out, and see myself out, and not return any data. So even though we have all the reasoning steps coming back, it says, hey, this is what I'm seeing. This is what I'm looking at, what we're doing. And then it comes through and says, and I'm spent. Blows its load early and leaves us wanting. Yeah, Ty, it's just randomly failing in here. So one thing we could do over here in the exploit agent code, let's see. Where would that be? That would be down here in the revisor. So here's what actually makes the language model call right here. It then appends our response, and then we check for the output right here. I think what we'll do is, let me take this out because I don't need that annoying debug in there anymore. I do need this, but I'm going to move this line up right here. We're going to move this up. And then we're going to do it. We're going to put this in a try loop right here. Oh, what do I want to do with this? It is supposed to return the scratchpad data as blank up here. So like if I look at a proper revisor report here, the scratchpad is a ton of data. So all this, everything in here, this is all the data that we're sending to it. And if we did not leave the scratchpad blank, we explicitly tell it that, then it's got to regurgitate all these tokens back to us. So what we do is we tell it, hey, you just go worry about all the other fields except the scratchpad. Don't do that. And then we repopulate those fields before we stick it back in the state table. So we have a copy of all this, a state table of the data. We send it to the language model so it can process it, so it can see it. But we tell it when you return back, just leave it blank. Leave the scratchpad blank. When that data comes back, we repopulate that scratchpad and then we save it to the copy of the state table. So that way we can save ourselves a little bit of money on tokens as it's coming back. Plus, it's just a ton of data. It would really bloat the output. Wonder if it's freaking out on that? I don't know, maybe. Possible? Possible? I don't see how, but here's what I'm thinking though is what we can do is we could put in a try loop in here. So we know what the error is going to be, right? We can tell it, hey, you're going to go try this in here. Let me try something real quick. Python retry loop with delay. Let me see if there's an excellent way to kind of run through this. I think the retry decorator, though, is particular function. And we're not calling a function in here. And technically, it's not failing. Let me double check. Maybe I can do this because I already have the retry put into here. We're already using retry. Yeah, here's where it's actually, yeah, this is a decorator on the function. Yeah, because I think this is a processing error on the language model. So what we could do is we could have it basically try it over again. And we already do this in... Where did I do that? That was in utils. I believe that was in LLM helpers here. So we actually already have the retry decorator happening here. And in fact, if you notice that when we call this, we're using the function LLM invoke retry, which is this one, and it's got the retry decorator on it. But the problem is this is not where it's failing. It's just the data coming back is dunzos. It's returning back blank data. So what I'm thinking about doing here is So what's the exception we're throwing here? Let me get the actual exception we're tossing. So we're getting a key error on this. Oh, my little timer just went off. I need to add a little bit more time to it. Here. So it should be a key error right here. Let me think about this. I'm just going to catch the error and pass it, and I'm going to do this like quick and dirty. So for I in range from 0 to 3. This is good. This is sucky. But I'm going to do it anyway. I don't remember actually if we have a sleep function in Python. Oh, it's time.sleep, that's what it is. And I believe that's in milliseconds. Oh, is it just regular seconds? I think we can do that. Is Hack the Planet better than Hack the Box? Absolutely. Predates Hack the Box by at least 30 years. I'm trying to remember, does this actually take... I just need to know if it takes a second or a millisecond. Oh, so it actually does take seconds. Okay, so pause for 3 seconds here. I need to import time. Did I import the wrong one? I did. There we go. So we'll just sleep it for 3 seconds, because then what we're going to do is we're going to run through it again. But if this actually works, is you just break out of the for loop, right? I'm trying to remember. I'm brain fried. Break out of for loop. Yeah, we just got to send it the break then. Yep. So if this completes, then we'll break out of the for loop and then we'll continue on with it. So it's going to retry it 3 times in here before it finally just bails out. That's so dirty and ugly. Yeah, but there's 2 different libraries called time in here, so I had to get the correct one. You just have to sleep for 1 second, actually. Because it's not like a timing issue. It looks like it is a... Okay, fine. We'll do this. Will that make you happy if I put that there? It's fine. I'll just ignore that. All right. Now, did it actually load this code up? Let's see. It's probably going to complain to hell and back. No, it actually looked like it did okay. I'm going to see if I can time travel this real quick. Look at all that data. So much. There we go. Rerun from here. So what we're doing is, like I said, every time the data passes between each of these nodes, it is getting a full copy of the state table. And look, it seems like, hey, it looks like everything's working in here as we go through this. It just returns that exploit step updates and just bails on us. And there, that time it worked. What the hell? People think this is going to take jobs. Yeah. Although, in all actuality, this could be an issue not with the language model. If I really wanted to know, I'd probably have to go actually put in like some kind of low-level packet capture, but I don't want to do that. This could be just an issue with the way LangChain is actually processing it. If it works, who cares? If it's stupid and it works, then it's not stupid. Key error on updates. Why did it not? All right, hold on. Let's look at this trace then. So what's throwing the error here? So it's literally this one on line 397. Hang on. Isn't that the one we just modified? Oh no, it's this step right here. This just, all that did. I'm an idiot. Output can equal the response. I'm a dummy. Yeah, because I'm an idiot. So what happens here is the response comes through. This try catch is completely useless because I forgot the line that's actually breaking is this one right here because it's trying to check it. It has been a long day. Ugh. Alright, unfortunately that is where I need to wrap it up because it's like 2 in the morning here. But actually it looked like there were some folks on InfoSec streams. Let's go look. There's no way Hack the Box is online right now. When was he live last? Let's see. Last live like 3 months ago? Nah. I just don't think he has the VODs up. Let me see. Yeah. When was the last time he was online? Alright, we gotta go find somebody to raid out to real fast. If you have any raid suggestions, by the way, on Twitch, feel free to shout them out. Let's see. What do we have? Oh, yes, Gumby.
Incoming transmission from Marano Gumby. This is your friendly nightly reminder to push it real good since we fix it, hee hee.
Teehee. Alright, I think all that is good now. Nightly push. Yep, there we go. Push. There we go. Hey, Wolves, thanks for hopping online, man. Welcome in. Welcome, welcome. Let me see. What do I have that I'm following right now? Jay Blow's on. What's he doing? He's playing Q Up. Dude, Science is still on? No way. Has he been on for 30 hours? Okay, that is just blatantly lying to me. You might have just gone offline. Let's see. Let's see who might be on. Raid J Blow? Alright, we can go raid him. Let's see. Actually, let me see if he's actually online. I don't know if he is. Is he still online, Gumby? I did F5. I think the Twitch interface is just jacked up. I don't know why it's not showing up. Being dumb. I thought it was J_blow. Yeah. No, he's not online right now. I think the interface earlier was lying to me, saying he was online. I've been wanting to test Graphene OS, but I need to get a new phone before I try that. Oh, you know what? Hypnotic's on. Maybe we'll go right over to Hypnotic. Check out Xerxes Black Crow. Alright. Let me go check him out real fast. What are they working on? Doing fun stuff. Build the game. Okay. Yeah, we'll do that. Alright, guys. Yep, I need to wrap it up there because it's 2 in the morning. Sock's already going to be pissed at me in the morning, but she's not pissed at me right now. I will catch y'all on, I think, Wednesday night. Yeah. Normally we do news on Wednesday night. I don't know. We'll chill out and we'll play some games. I don't know. Since it is Christmas Eve, right? Is that Wednesday? Yeah, holy crap. That'll be Wednesday. So, all right, guys, y'all take care. Have a great week if you're working this week. Remember, we're still in crushing it mode, but crush it gently. Be tender as we go into the week for Christmas. And if you can, go spend some time with your friends and loved ones. And I want you to remember one very important thing. I love you. Peace.